Okay. Welcome to day 2 then. Okay, so let's go through this again. We're going to talk about EC2. Our day is pretty much going to be about EC2. And then we're going to do a lab, which actually we did the EC2 lab yesterday. So I'm so glad we did that actually. So we got, our hands-on stuff kind of engaged, which is, I think, super important. Bear with me just 1 second. Being asked to sign in. Pardon me. Oh, so weird. Anyway, the new skill builder site, by the way, with its supplement, I think we also talked about that yesterday. I am going to upload a little file that has a bunch of like relevant links that is also going to go in the material section. So just know that I'll make sure that you have some of the links that we covered, including ec2instances.info, right? We talked about that as well. Hold on, let's see here. All right, that was the online course supplement. And then we had the schedule. Okay, perfect. All right, so let's talk about EC2. So as far as our pricing options go, this is kind of a review of the different types of instances that we can use. I just want to mention that dedicated, which is also a type of instance that you can use, is probably not really included in these pricing options because it's really more of a security, like single tenancy, like dedicated tenancy option. It is the most expensive way, but it's not really considered like a virtual machine licensing type. This actually, dedicated instances and dedicated hosts actually give you a physical box. So, that's a slightly different kind of engagement, if you will. So, yeah. So let's talk about this. So we yesterday reviewed about the 4 different kind of possibilities as far as like saving, money when it comes to AWS. So here we talked about reserved instances and savings plans, which were really like a 1 to 3 year commitment that you could make around, I'm going to either with reserve instances, I'm going to commit to having a certain size of virtual machine in a certain region, in a certain availability zone for 1 to 3 years. And then savings plans were more along the lines of, I'm going to have a bucket of money that I'm going to give to Amazon, and they're going to give me extra money as a result. Like they're going to give you a discount. They're going to give you a discount on the hourly compute that you have. And in truth, it's not that they give you actually more money. What they do is they give you a cheaper rate for your compute because you've paid them a bunch of money up front. Do know that with savings plans, let's say you give them $10,000 and you've only used $9,000 and you've done that for a year. When that year expires, that $1,000 goes away as far as it being available to you. So most people, by the way, are not super concerned about that because they usually underspend when it comes to committing to reservations or savings plans. So for the most part, people are expecting their loads to grow more than they like thought, right? So, so just know that 1 to 3 year commitments, savings plans are about you giving Amazon money, reserved instances are about you committing to using a certain type of instance in a certain location for 1 to 3 years. So when we started running into this, in order to kind of peel this back a little bit more, they noted that there actually are 2 different standard reservations types. There's the standard reserve instance, which is just the one I described. I'm going to use an M5 extra large in US East 1A, or I'm going to use 5 M5 extra larges in US East 1B. Those are availability zones, right? And so this way you're like saying, hey, I want to, commit to having these virtual machines running 24/7, and I'm going to pay for them 24/7. Now, the other option is you could say, instead of committing to only having that specific size of virtual machine with the convertible reserved instance, what you're saying is that, Amazon, I want to run the M5 family in US East 1, in Virginia, in A and in B. But what I want to do is that in A, I might want to combine all my reservations to either make a bigger virtual machine, like a bigger M5, or I might want to separate my M5. Let's say I got an M5 2X large. Can I make it and separate it into two 1X larges, right? So just know that convertible reservations, they obviously only give you up to a 54% discount, but you have more flexibility about how you t-shirt size your reservation in that region, in that availability zone. So also know that when you do standard and convertible reserved instances, that you actually have to choose your tenancy and you have to choose your operating system. So like if we were to go look at, so for example, here, if you wanted to make a reserved instance, you can just click over here on the left-hand side. And let's say you wanted to purchase some reserved instances. So notice that these are the questions it's going to ask you, right? They want to know, first of all, what size of system do you want? Do you want it for 1 to 12 or, basically 1 year or 3 years? Do you want to put some money up front? The more money you put up front. So let's say that over 3 years, this T3 Micro would cost us $10,000. If I put up $10,000 right now, they will give us 72% discount on the hourly rate, right? And it's, it'll be like ridiculous. So, and then, so let's say, notice that this is Linux and there's SUSE and then Red Hat and then Windows. So you have a couple of options that if you like in terms of operating system. So let's say that we're going to do shared tenancy, which is the default. I'm not going to do convertible. I'm just going to do standard. And I want to do Linux. Here's a T3 Micro. And I'm looking for, 1 to 12 months. And I don't want to do any money up front. Not interested in giving them any money up front. So I'm not going to get the actual like maximum 72% discount. But I wouldn't have gotten that anyway because I'm only doing 1 to 12 months, right? So let's take a search here, see what's possible. So notice, by the way, there's some third parties that are selling their reservations. There's like other companies. You can actually resell your reservations to other people, and they are often not as cheap necessarily as what you can get from AWS, right? So for example, here's a 12-month rate, no upfront, standard, unlimited, normalized units per hour. By the way, so the effective rate is 0.007, which I believe is half. This is a 50% discount, if I remember correctly, off of the 0.014 that you usually get for a T3 Micro. And then I can just add that to my cart, and we're good to go, right? So notice that that was a standard reservation, and I got 0.007, right? So I'm going to add that to my cart. Let's say I switch this to a convertible reservation, and I search. Let's see if AWS has anything here. Notice that for just a small bump in price, right, it now went to 0.008. That's it. Now, let's be clear, that's a 16% reduction in savings, right? Because I went from 0.007 to 0.008, right? Add this to the cart, and now I've got these in my kind of offerings. But these are the questions that it asks you when you go to do reserved instances. Is it's going to ask you, hey, answer these questions for me. Now, notice, by the way, I'm doing 1 to 12 months, so I'm doing 1 year. If I switch this back to standard, remember that was 0.007 cents an hour, and I do a search on this, and I want to see if Amazon has capacity, notice that it goes from 0.007 to 0.005. That is at least a 30% drop, is it not? 16%? Wait, is that right? No, 15%, give or take. 14, so 14 times 2, so that's a 28% drop, right? So 28% drop from 0.007 to 0.5, that's standard, right? If I switch this out to convertible and search for it, oh, look at that. It's still 0.005. But I bet you there's probably some extra numbers there that round this up closer to 0.006, whereas the other one, right, maybe rounds down to 0.005. So that should give you a feel that convertible options allow you to t-shirt size up and down, but standard options are very specific. And note that even though it hasn't asked me yet, it is going to want to know where I want to reserve this capacity. Do I want it in this data center? Do I want it in this data center? It is going to ask me those questions, right? So if we view the cart, right, here's the commitment, here's the hourly price. By the way, sometimes I do that for my demo accounts is I'll just leave a machine running and just have it like, like a Cloud9 or something, and I'll just go ahead and reserve. So if you multiply this times, let's see, Let's grab this. So there's 365 days in the year times 24 hours, right? That's 8,760 times 0.007. So I would pay $61 the entire year for that T3 micro, which by the way is like a 1-core, like I think 2 gig, 1 gig machine, right? So $60 a year for that whole thing. So now, what if I wanted to delete these from my cart? Let's delete them. There we go. Cool. All right. So hopefully that gives you a better visual about how reserve instances work and the differences in pricing between convertible and standard. Any questions there? No? Okay. Let's see, Mr. Yu, I saw that you had a question in there as far as is there a limit to labs when the retry if I start and stop hands-on? And will the labs only be available for the duration of the training versus beyond the day training? So good questions. So yesterday, let me pull this up. You may note that when we were looking at the class yesterday, and I was kind of like showing you all of the classes that at least that I taught recently. This is architecting on AWS. You have access to these labs until February 15th. So you have access until February 15th to do the labs. You can usually only do the labs like maybe 2 or 3 times before they lock you out. So at most you'll get to do the labs twice. You might get to do them 3 times. So I just want to make sure, Mark, that you were super clear about that. So Calvin, good question. So let's clarify that a little bit further. So let's go to that ec2instances.info that we were just talking about. And let's come here and let's put in the T3s. Sorry, still loading up. Giving it a second. Giving it a second. And we're loaded. Okay. So let's say we're doing the T3 series, okay? And I'm going to sort it by memory so you can see it. So see how it goes from nano to micro to small to medium to large? When we go to make a reservation, when we were just on that reservations page that I was just showing you, we actually have to, let me put this out of the way. We actually have to, where did my console go? There we are. We actually have to come in here when we make a reservation is that we have to specify the size of the instance, right? So regardless of whether it's a standard reservation or a convertible reservation, we have to basically tell them what size of instance we want to reserve for 1 or 3 years, right? So for 1 or 3 years, let's say we want a T3 micro. But let's say instead of getting 1 of them, we want 10 of them. We want 10. So Calvin, just to follow me, let's say we get 10 of these T3 micros. Now, the reason this is significant is that notice that the T3 family includes a nano, a micro, a small, a medium, a large, an extra large, or a 2x large. So what does this mean? What this means is that when I make a standard reservation and I get a T3 micro, I'm going to say to Amazon, I want this machine for 1 year, and I want it in Virginia, US East 1, and I want it in data center 1, which would be A for Virginia, so US East 1A. And a standard reservation, I tell them that I only want it for that 1 year, and I can pay partial, and I cannot change the size of that instance. I cannot touch it. I cannot move it to a different region or location. It has to stay a T3 micro in Virginia in data center 1. That's a standard reservation. Again, 1 or 3 years doesn't matter. No upfront, partial upfront payment, or full upfront payment doesn't matter. They all operate the same in that way. But if I get a convertible reservation instead of a standard reservation, what happens is that if I have 10 of those T3 micros, I can take 2 of them and combine them, and then I can actually launch a T3 small. If I take 2 of the T3 micros and combine them into a small, and 2 more of the T3 micros and I combine them into a small, and I have 2 smalls now, so I have 2 T3 smalls. If I push those together, I can now get up to a T3 medium. So they're a little bit like Lego blocks, is that convertible reservations allow you within the same family to combine multiple reservations together to make a bigger box. So if I have 10 well, let's say 8. Let's say if I have 8 T3 micros and I combined like them together into pairs, I'll end up with 4 smalls, 2 mediums, or 1 large. You following me? So think of this as being like being worth like a point. This is worth 2 points. This is worth 4 points. This is worth 8 points. So I can literally, with a convertible reservation, if I have multiple convertible reservations, I can smash my points together to get a bigger machine. But it has to be a T3. It can't be another family type. So let's see. If I took this T3X large and I broke it apart, I could get 2 of these T3 extra larges, right? Because 32 points down to 16. I can break 16 down into, right, 2 of these. So let's say I can end up with 4. So if I bought a reservation for 1 T3 2X large worth 32 points, I could get 2 of these TX larges. I could break that out into 4 of these because 4 times 8 equals 32. I could come up with 8 mediums because 8 times 4 equals 32. I could then come out with 16 T3 smalls because 16 times 2 equals 32. Hopefully you get the math at that point in time. Does anybody not understand what I just did with convertible reservations? Cool. Yeah, so yeah, no, Calvin, thank you for asking, actually. That's an important thing to explain. So, and by the way, that point system that I just came up with, I just use that as an example. You have to actually look at the points for each of the reservations. So you can do the math easily, but I just made up those point vet systems. It doesn't match the memory. You have to look at the documentation. All right, I'm all ears, sorry. Or sorry, George, I'm not sure how to pronounce your name, actually.
Right. Can you hear me?
Yes. Is it Jorge or is it George?
It is Jorge.
Okay.
George, well, if for the Spanish impaired.
Okay.
The question is the convertible, as I hear it. As long as it's equivalent, what if I buy a 3 micro convertible and I just want to keep adding to it?
What do you mean by adding to it?
Basically, 3 micro, and then after running some tests, geez, should be in a T3 medium instead of a micro.
You probably have to buy 3 micros. You have to buy 3 more micro convertibles and then smash them together to upgrade it.
Then it's an equivalent. It's just not upgrading. Okay, yeah, that just clarifies it.
No, that's a good question. Yeah, the value has to either match or exceed what you would like. Match or be less than what you had before.
Yes.
So, if your total points are 32 and you want to split into 2 16s, totally fine. You want to split into a 16 and an 8, that's totally fine, as long as you do not exceed the value of 32, which was the original convertible that reservation that you bought.
Yes.
Yeah. So unfortunately, you don't round up on that. So it's a good question. Yeah. You know what? I sometimes in my head I realize that I need to become good at JavaScript, which I'm not really good at. I'm pretty good at Rust, Go, and Python. Just so I can like create websites that have these visualizations on them that can go with my explanations. So maybe that'll be my focus for 2022. So, all right. So that's reserved instances, right? So that's reservations. Now, here's another catch that most people don't know. When you buy a reservation, that reservation is with you until it expires. So if you decide to not run your T3 micros because your project ended early, you still have to pay for the T3 micros even if you're not running them. That sometimes scares people, but just to say this, companies move really slow on migrations and transitions, and I don't know that I've ever been with a company that's actually retired a product. You know what I mean? Like they've rolled out a new product and retired a product, but they never just like cold cut a customer off from a product. If that thing's still making money, they just keep it. So don't worry about not like paying for something. If you buy 10 T3 micros, either sell them on the marketplace or upgrade them to a more usable machine. Don't worry about that. But the one thing I will tell you is that the other thing that people don't know is that Amazon charges you for the entire month for your reservations at the first of the month. So people will freak out because if that thing costs, $60 a month, it's going to show up at $60 a month on day one, but then you're not going to get charged for the rest of the month. So if you ever have to look at somebody's bill, don't freak out if you see that, okay? You're going to get charged for your reservations on day one, but you're not going to get charged for them for the rest of the month. So if you ever have to look at a bill, just be aware of that. Okay, so that's all reserved instances. This is us reserving virtual machine capacity. What if we want to go do a savings plan? That's the second type, right? Same 1 to 3 years, right? But what this does is that instead of making commitments to 1 to 3 years of a specific instance configuration in a specific location, you can actually either get what's called a compute savings plan, or in our case of what we're interested in, you can get an EC2 instance savings plan. So the savings plan, basically, for example, in exchange to use like an instance family in a region. So for example, we're gonna use M5s in a region. That's an EC2 savings plan, by the way. There is a compute savings plan that will give you up to 66% discount, and you can just use whatever EC2 instance, whatever container, and whatever Lambda you want. So there are two, like technically EC2 plans, if you will, that allow you to consume virtual machines. The instant savings plan does require you to make a commitment to a particular family type, much like the convertible. But the general compute savings plan will cover Lambda, containers, and EC2, and it does not care what OS, tenancy, family size, available. It does not care where you put this box because you're eating out of your bucket. So if we go to get started, what's going to happen is that it's actually going to redirect you to the cost management page because there's a savings plan section here, and they're going to make sure you understand. And by the way, there's machine learning savings plans as well. Just put that in your back pocket. But there's the compute savings plan. Here's the instant savings plan. And what you can do is you can say, look, I want to purchase one. Now, if we do an instant savings plan, they're going to ask you for your term, 1 or 3 years. They're going to ask you for your region. Let's say we're going to go US East 1. Notice, by the way, all of these local zones that are here. There are local zones mixed in. Because notice, there's no region in Miami. There's no region in Minneapolis. There's no region in Kansas City. So all these names that you see that are not official regions, North Virginia is the only one, and Ohio are the only ones on the East Coast in the United States. The rest of these are all local zones. And then it gets even weirder, which I'm not even talking about. But let's say we do North Virginia. And then here's the family type. So if I'm like, man, I really am in love with the T3 series, it's going to keep the T3s, right? And then what's our hourly commitment, right? Then what happens is that you actually have to like look at the applicable rates and see the recommendations for like how to what do you want to commit to as far as like the amount per hour that you're willing to deduct against. And then you set your start date and time. This, by the way, has a little bit of a deeper meta to it, so I'm not going to go into deep into it. But let's say it was $1, right? Set the start date. Let's say it was the 1st. And I don't know, do I really need to pick a time? Okay. Say 8 o'clock. Here's my monthly payment. Here's my total cost. Let's say I add that to a cart, right? And what's going to happen is that they're going to be, if I commit to $1 an hour, they're going to greatly reduce what I'm actually going to spend over the course of the actual month, because my monthly payment would be $730. And so what's happening is that they're going to come back to me and give me basically, up to a 73% discount over the value of that dollar. So instead of me paying $1 for the actual like compute, they're going to give me basically an extra, let's say 50 cents worth of compute. In other words, the value of that dollar is going to be longer. They're going to give me a discount on what I'm going to pay per hour against those instances. Amazon loves this because you're actually committing to paying them a certain dollar amount, and they're going to give you an extreme value and commitment for you, like paying that money ahead of time. These savings plans, by the way, will pay at the first of the month, just like a reservation. So to make sure this is super clear, in exchange for me paying $730 a month for compute, they're going to give me up to 73% discount off of that compute. So this works a little differently Because while I have committed to using T3s, right, and I've committed to doing it in Virginia, right, this is more dollar focused and not necessarily capacity focused, like exactly which T3s am I going to be using. Now, if I went in and added another savings plan, and this time instead of doing the EC2 one, I do the compute savings plan, notice the only thing they're asking me is what's the term, what commitment am I going to do? Let's say it's $1. I'm not going to do anything up front. I can set my start dates if I want to, but let's say it's the 1st. Let's do the same thing. Same thing, right? Wait, did I say all up front? I wanted no up front. There we go. So what will happen here is I actually don't know the full range of discount that I'll get, but the compute savings plans is probably going to be slightly less because the maximum they're going to give me is 66% discount. And so what will happen is that dollar will actually be worth like $1.66 instead if I was getting the maximum discount. So as I was consuming compute, right, and notice I haven't committed to a family type down here with this compute, it's any family type. They're basically going to make that dollar more valuable because I'm giving it to them up front and I'm committing to do it up front for a long time, for a year, right? So remember that the savings plans are money focused. They're not necessarily focused on instances, although this EC2 instance version is actually focused on an instance in a specific location. But the general compute plans are not necessarily instance focused, okay? All right. So that was the savings plans. We talked about the instant savings plans and compute savings plans. We didn't talk about SageMaker. By the way, most people don't know about these savings plans and don't know how they function. So you're one of the few who have been exposed to the fact that you can actually buy, savings, discounts against your dollar, basically. Think of it as a coupon. Notice here the 66% and 72% and 54 and 72%, blah, blah, blah. The main thing you need to know is that if someone needs flexibility and they want the highest discount and they're using reservations, they have to use convertible RIs if they want flexibility. If they don't need flexibility and they know what their workloads are going to look like, then they're just going to use standard RIs. If they're like, we don't want to do reservations, we just want to give Amazon some money, and you want maximum flexibility, then you're going to use a compute savings plan. If you want flexibility within a particular family type in a particular location, and you want to give Amazon money, you don't want to reserve capacity, you just want to reserve a particular family type, then you use the EC2 instant savings plans. So those are the distinctions, right? Note, by the way, that the compute savings plan is the only one that applies across all regions, across all compute types, right? Across all OSs, right? So it has a lot of flexibility around that. Oh, sorry, I said all OSs. The EC2 Instant Savings Plan also applies to OSs, but mainly when it comes to other compute in any region, the compute savings plan is unparalleled. Okay, let's talk about spot instances. Any questions, by the way, about reservations or savings plans? No? Okay. So Calvin, that's a good question, actually. Which plan is the most popular? So I would say that most people are still using reservations, probably convertible reservations, because as you saw, the discount's still high, but you still have flexibility. So convertible reservations, in my experience, are probably like the most popular. But I'm seeing people go after the compute savings plan, not the EC2 instant savings plans, a lot more because people are using Lambda and they're using containers a lot more. So particularly if it's a startup and they're not using virtual machines, they're using compute savings plans because that gives them ECS and EKS, the container services, and it gives them Lambda, which are the things that they're mainly using. And so if it's a new startup, they're using compute savings plans. If it's an established company that's using virtual machines, convertible RIs are most likely what they're using. So it depends on the demographic of the company. Yeah, you're welcome. All right, so let's talk about spot instances. So spot instances, I used to call the eBay of EC2 instances because you used to bid on these instances. You used to be like, hey, Amazon, I want an M5 X large, but I don't want to pay $1 for it. If you have extra unused capacity and the price drops down to 40 cents, give it to me. And you can take it back if you need to, right? And this was kind of fun, but frustrating because you had to kind of guess what was going on with Amazon's infrastructure to know whether or not they were 100% used or 50% used or 10% used. Like at 3 o'clock in the morning on a Saturday, everybody scales down. So nobody's using Amazon's infrastructure because they're using auto scaling to scale their stuff up and down. So you could get stuff for 90% discounted at 3 o'clock in the morning on a Saturday, which is crazy. Then you could run massive parallel batch reporting on Amazon's infrastructure, and they were happy because at least they were getting some money off of their unused infrastructure, right? So notice it actually says 90% discount compared to the on-demand price. But when you put in a spot request, there's no more of a guessing game around this anymore. Instead, you actually go into the console and Amazon tells you what they're going to offer their extra capacity at, right? So if we go back to EC2, oh wait, that was already there. What did I switch? So here's some spot requests, by the way. So if I go into EC2, and let's say I want to come in and request a spot instance, what will happen is that let's say I want an Amazon kernel. Oh, look at that. That was that problem I think that we ran into yesterday. And, let's just create a new key pair because I think I deleted all of mine recently. By the way, what are key pairs used for? May remember? What are key pairs used for? No? No one remembers? I'm a horrible person. You guys don't remember what key pairs are. By the way, note that because I updated it into a separate console, you have to go over here and hit refresh, and it'll automatically show your new key pair. Any other launch parameters? Maybe I want EBS volumes, or maybe I want to update the size or whatever. Anyway, as you come in here and you actually create your instance, like including like a request details, you can say, look, I want 20 spot instances, right? And I want to set a maximum cost that I'm going to pay per hour, right? So, most, by the way, could be, and by the way, you never pay more than on-demand price. So if the instance costs $1 an hour, in spot instances, you can never pay more than $1 an hour, right? By the way, the key pairs, because I just saw all your responses, I don't know why they were delayed, are used to log into EC2 instances, in case you missed that. So then you can specify the network, all the availability zones, or just balance across, specify the instance types, blah, 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 allocation strategy, maybe you want the lowest price, or maybe you want capacity. And then what will happen is that they're going to give you your estimated price for the 20 instances, right? Notice they're going to tell you also how much you're going to save. And when I launch this request, what will happen is that Amazon will automatically give me these instances the minute it meets or beats my price. If I do not specify an Amazon machine image that is ready to go at launch, which none of these are, by the way, because they're going to have to do some work to get these functioning. These are base images, right? But I don't have them configured for me. And by the way, if I have AMIs, they should show up in there. But you should have your own AMIs. And if you win the spot bid, that system's going to boot. It's going to get straight to work. You're going to start working. And then you might have it an hour. You might have it a day. You might have it for half an hour. You're going to get a 2-minute warning. It's going to shut the instance down. So you got to make sure that you're writing data out either to a data store or to S3 or to persistent storage if you want to keep that data, okay? So this is how you basically start a spot fleet request, and Amazon will tell you exactly how much it's going to cost you and how much you're going to save, all of the availability, by the way, which by the way is strong. That means, by the way, your request is likely to be fulfilled. This is as much of an art as it is a science. but they've taken a lot of the art out of it. So if you see that that's weak, you might need to go in and change some parameters to make sure your request is handled. By the way, this is going to fire at 3 o'clock in the morning if I put this in here. So it's going to fire at any point in time as long as you leave this bid active. So I could leave this bid active all month, start up my reporting AMI, have it run, 3 or 4 times over the course of the month, get my report done, and it's 90% discounted. Now, notice in this case, I'm actually only getting a 75% discount. But if that report costs $10,000 of compute for me to finish, and I only spend $2,500 to get it done, it was probably worth the 20 or 30-day wait to get it to happen, especially if it's not due until the 1st of, January, right? So I know this looks like really complicated and annoying, but I do want to point out one little thing, because we don't have really a workshop on this. If you have a free Amazon account, you can actually run a lab called ec2spotworkshops.com. I'm going to post this in the chat. And this will allow you to actually play with spot instances and get a feel for how this functions, because we don't have a lab on this. I wish we did. This is published by Amazon. It's not listed really in a lot of places. But this will actually, if you just do that first load, the first one that says launching spot instances, this little free lab that you can access at any time, not just for the duration of this class, it will actually set you up for how to run AWS spot instances via autoscaling, okay? So I just want you to have that, because if you want deeper exposure and experience and understanding for EC2 Spot, this is how you get it. But the main thing that you need to know for our purposes today is that you set a bid. It has a certain bunch of questions being answered, as you just saw, and then instances are given to you, and you have a 2-minute warning when they're taken away, but you can get up to a 90% discount. That's what you need to know, okay? If any question on the exam says this application can withstand interruption, it can be interrupted. It can be interrupted. If the word interrupted is in there and they're asking about EC2, the answer is probably spot instances, okay? So thus far, we talked about dedicated instances. Yes, earlier, just as like a most expensive way to use Amazon, and you can get access to bare metal hardware. Then we just talked about reservations, both standard and convertible reservations, and then we just talked about savings plans, and we just had a conversation about spot instances. Any questions about any of that? Okay. Ideal workloads for spot instances. Anything that is stateless, writes its state out, or can be interrupted, or both, right? Preferably. By the way, what some people will do is they'll buy reserved instances for like their base. This is like the minimum like business continuity. So like maybe 2 instances, they'll buy reservations. Then for their burstable capacity, they'll buy EC2 savings plans. And then for really unexpected capacity, what they'll do is they'll either bring in spot instances and or on-demand instances to cover like all of a sudden these variations. Like let's say you're running along and you know that you spike between 50 and 100% between your boxes. The 50% of the boxes could be reserved instances. The other 50% could be part of your compute or EC2 savings plans. But let's say you got a day where all of a sudden you're at 150% capacity for your servers. That extra 50% above the 100, that could be spot instances or on-demand instances. So just know, people do combine these instances, and especially if you're a consultant or working for a company that doesn't know how to maximize these licensing types, you are losing money on AWS, right? That you could actually just literally leave on the table, right? So just know that if you're only using on-demand, that is by far the like I would say second most inefficient way to use AWS. You want to be using these other licensing types. Okay. Question about pricing options. Do 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 do. You ever wake up and just have like a song in your head? I haven't seen the Muppet Show since I was like 3. I had the Muppet Show in my head this morning. So weird. Human brain. Okay.
I have a question. I have a question.
Yeah, go ahead, Maria.
So let's say you reserve all this and you paid Amazon and you decided, I'm going to bail out at Amazon. Is there a way to export all your OS, I mean not OS, but applications and everything out of Amazon, or are you stuck with whatever they give you?
You mean if you're running them on a virtual machine, can you export
Yeah,
them out? I
yeah.
mean, it's just a virtual machine. You can take them in. You can put them in anywhere you want to. You
So
just
it's like a VM. It's like a VM.
yeah, it's just a virtual machine. You can redeploy them.
Okay.
Yeah. So like if you wanted to take it out of Amazon and put it in Google, you just start a virtual machine over in Google and just kick it over there, right?
Okay. So it's like a VM. Okay. Got it.
Yeah.
Thank you.
Yeah. The instance is just a virtual machine with an OS that you decide. That's all. And actually, I mean, pretty much everything in Amazon is like that. They do obviously have some proprietary services, but most of their services are actually based on open source software. So virtual machines are virtual machines, and I minimize that. They do actually operate differently between the providers, but as far as application deployment goes, it's all the same, right? So it's really easy to take stuff out. The things that get hard, they're not impossible, they're just harder, right? Is like if you're using DynamoDB, you just have to use a NoSQL system. But just to say this, all of them have comparable services, so it's easy to translate, especially if you're doing automated provisioning. Yeah. Okay, so our developer needs EC2 storage that supports 32 I/O operations per second. That's what IOPS is, right? Which is basically reads or writes per second against the disk. So first of all, if a developer ever says that to me, I definitely am going to hire that person and want to spend more time with them, because most developers that I've met don't know that, right? And don't even really care. They're like, hey, here's my app. I don't really know what it does. I mean, I know what it does, but I don't know how it performs. Systems guy, figure it out, right? Now that's changing a lot. You're finding obviously with DevOps and pieces that developers are more involved in that whole thing. But man, someone said I need 32,000 IOPS a second. Whew, that would be an impressive app. Just to say this, like Amazon has a bunch of options now that will support 32,000 IOPS a second. I think the main reason they're asking that question is that when you buy an EC2 instance, some of them come with storage. We saw this actually. So like, for example, we were over here looking at the T3s. Notice that they don't have any instant storage. So see this instant storage piece right here? Notice it says EBS only. Let's go look at another one. Let's go look at one of the M6s actually. Notice that some of these, like the M6 GD, like notice that these M6As have EBS storage only. The M6Gs have EBS storage only. But all of a sudden, if we look at the GDs, anything with the D in the name, it has a local SSD attached to it. What is that? Is that not EBS? EBS, by the way, is the Elastic Block Storage. That's a service that provides hard drives to EC2 instances. Well, then what is that hard drive like attachment there, as far as like there's an NVMe SSD attached to like this, M6 GD 2X large. What is that? 474 gigabytes. It's actually gigabytes, but gigabytes of actual SSD storage. Why? Why would Amazon do that? Well, here's what's happening. So imagine in a world where you are running your virtual machines and it's sitting on a big old host. And you've got another host sitting over here, but there's no virtual machine on it yet. But you've got a hard drive right here. Just ignore my squiggly lines. And this virtual machine is actually talking to this hard drive, right? If this host were to somehow go away, you would think that you could just restart your virtual machine over here, which you can, but you're going to lose this hard drive right here because it was specific to this particular host. That is instant storage. This storage is ephemeral, which means if that virtual machine crashes or the host crashes and it restarts on another box, that data is gone. You're going to get your hard drive back, but it's going to be a new hard drive. Your old data is going to be gone. So this is what instant storage is, right? General rule of thumb is that if you are new to Amazon, you don't use instant storage. As a matter of fact, if you're kind of good at Amazon, you don't really use instant storage. Most people will avoid the headache of using instant storage, but that's what it is that instant storage is basically hard drives, right? Now, the funny thing is that Amazon has EBS. This is an external storage subsystem. So as you can see here, this is separate from the platform that hosts the virtual machine. There is a separate service that offers hard drives to those virtual machines. That's why it says on here, EBS only. That means that it's using this virtual hard drive service to run hard drives. Now, you can create all the hard drive volumes you want on EBS without restriction. But if you use instant storage, notice that you are limited to the sizes that are listed here. So if you grab M6G at large, you are limited to 118 gigabytes of storage. If you use the EBS service and not that instant storage, you can create volumes up to 16 terabytes in size. So these EBS volumes are independent of the life cycle of the virtual machine. And so if the virtual machine crashes or is deleted, you can actually keep your hard drives if you want to. If you use the instant storage that's attached to these systems, that is actually completely dependent upon the life cycle of the virtual machine. If it crashes, you lose the data. Here you keep the data. With instant storage, you lose the data. Okay? So EBS is actually the hard drive service for EC2. You got to use that if you want to keep your data. EBS, by the way, allows you to create, attach, use, backup, then detach, and then delete hard drives through their entire life cycle. And that is completely separate from the virtual machine. Now, you can tie them together. You can make it so that if you delete a virtual machine, it deletes the hard drive. You can also make it so if you delete the virtual machine, you keep the hard drive. Now, EBS, and this is not instant storage, but EBS actually comes, and I noticed that, just to say this, they note the old generation. Forget the old generation. If it says GP2 or IO1, pretend that you don't see that. No one should be using GP2 or IO1. I don't even know why they list it here. Just know that it exists, right? Everybody should be using GP3 and IO2. Why? Because it's cheaper and faster than the previous generation. So why would you use the old generation? So there's two different family types here. At the top, you can see that these are SSD-backed volumes. At the bottom, you can see that these are mechanical hard drives. Does anyone remember ever having a mechanical hard drive inside your laptop or desktop? Do we want to go back to that? Yeah, I gotta tell you, I don't want to go back to that. So just so you know, those HDD-backed hard drives are really only used for archival and cold storage. Do not use them for anything else. The reason the GP3 and the GP2s with GP3 is called general purpose storage is because it meets almost every use case. Fast boot up. I watched a GP3 system. I think I told you this already. I watched a GP3 system the other day. One I saw at 30 seconds, one at 15 seconds, just booted right up. I mean, the thing, like a pure operating system with a Windows system on top of it, booted up in like 30 seconds. And then the one right after it, which had a really slim one operating system, came up in 15. I was shocked. That's what these disks do for you, right? So use the SSD back volumes. Try not to use the HDD volumes. There are use cases for the mechanical hard drives for ST1s and SC1s. SC stands for cold storage. ST stands for sequential throughput storage, streaming throughput, right? So just know that other than that, you're going to use GP3 for everything. And if you have a high database throughput, they're going to use IO2. but I just want you to mention this, is that IO2 is going to cost you more dollars for performance, right? So it's worth it, but IO2 is really for high throughput databases. Just to mention this, like GP3s cap out at like 16,000 IO per second. IO2 caps out at 64,000 IO per second. IO2 has a block express version that caps out at 256,000 IO per second. So if you're looking for a performant hard drive and 256,000 IO per second is not fast enough for you, we need to talk, because I'm really curious as to what you're doing that's going to exceed that, because that's ridiculously fast. So general rule of thumb, GP3 for common workloads that just require random IO. If you need high throughput random IO with a database, that's going to be IO2. If you want streaming workloads that are sequential, you want streaming throughput, that's what the ST is for. That's streaming throughput, sequential throughput. And then the SC one is pure cold storage. Okay. That was a lot of information. Yeah, my memory still works. That's good. So here's the stats, right? Notice I said that everybody goes up to 16 terabytes. Amazon just released IO2 Block Express, like I want to say like within the last 6 months. Notice that you can get up to a 64 terabyte volume with that special little subset of IO2. Notice that the IOPS go up, right? So you go from 16, right? Then you got 64, then you got 256,000. And by the way, the GP2s and GP3s, there's obviously some burstability there. Anyway, see the max throughput for volume? So 250 megabytes per second versus a gig per second versus a gig per second versus 4 gigs per second, right? So you can get some really good throughput on these systems. You probably want to memorize this for the test. If you're going for certification, you got to memorize this. There's just really no way around it. I don't think IO Block Express is actually on the exam yet, but if you're going to take the exam, you're going to want to memorize, okay? Now, notice those differences in numbers here. Max IOPS is 500 versus 250 for the ST1s and the SC1s. Notice you got, what is that? Half a gig, right? If it's sequential. If it's random IO, you're not going to get half a gig of throughput through that ST1, and it's a quarter of a gig for cold storage. Again, only if it's sequential. So notice that, by the way, they all cap out at 16 terabytes. So who cares about the minimums, really? But 16 terabytes max. Okay. There is some math, by the way, around these drives. So the smaller they are, the less throughput you get. So sometimes in order to get maximum throughput, you actually have to go up to like a 4 terabyte volume. So just know that just because you're running a 1 terabyte volume doesn't mean you're going to get instantly a gig of throughput. So just something to realize is that you're going to have to read the documentation if you want to maximize throughput on these. Now, I just went back and forth about instant storage and EBS, but we just spent all our time on EBS, right? But I just want to remind you that instant storage is ephemeral. That instance is terminated, which you can't stop it, by the way. And so if they ask you on the exam, what happens to your data if you stop an EC2 instance that has instant storage on it, the answer is the data is deleted. Okay? So just be aware of that.
Review. If you stop, it's deleted. It's not the stop. I'm looking at the picture here, and I still see it. I see, obviously, when it's terminated, there is nothing. But stop is kind of like pause, or stop is kind of like reboot if you go back to it.
So if you use instance data that has the C drive or the root volume on your instance, you can't stop it. But let's say you put an EBS volume in there and you actually still want to use the instance storage that's attached to the instance for free. If you stop it, it turns off the operating system. It's the same thing as powering it off, right? But you're not giving it back to Amazon, you're keeping it, right? You're just keeping it in your account, but you're shutting off the usage of it. And you're not paying for the compute anymore. But if there's data on that hard drive, it's gone. If there's data on an EBS volume, the EBS volume is attached to the instance and is still sitting there waiting for you to use it.
Okay, clear.
Yeah, yeah. So think of it like when you terminate an instance, that's like you giving your laptop back to the vendor, right? But if you just power your laptop off, the laptop's still there. You just need to power it on if you want to turn it on again. Now, the problem is that with instant storage, if you power it off or you terminate it, obviously you lose access to your data on that drive. But again, if EBS is also attached to this instance and you've got instant storage and you've got EBS storage, you're not going to lose the EBS storage unless you ask it to be deleted. So, okay, let's talk about high performance computing. Then we're going to talk about serverless. And then we're going to have a conversation about storage, which is actually one of the longer conversations that we have. Okay. All right, so this one, by the way, you just need to know. So with high performance computing, unlike disk drives, right? When we approach this conversation, what we're trying to do is that we're trying to take computers and actually put them on the closest together that we can. We are not maximizing for high availability. So imagine you've got 15 physical boxes that you could run your virtual machines on, and you need 10 of them. Ideally, you would run all 10 of your virtual machines on one of those physical boxes. Why? Because then everything happens in memory, right? If I distribute those 10 machines across 15 physical hosts, then they have to go across the network and go do all this stuff to talk to each other. If I want 10 boxes in a high performance computing cluster, I'm going to stick them on the same physical box, right? If I want 10 virtual machines to talk to each other as fast as they can, I want to stick them on the same physical host because I don't want to have to traverse the network to have them talk to each other. If I stick them on the same physical host, all in memory, okay? So Amazon has an answer for that if you're willing to sacrifice redundancy to a certain degree. Now, they've got a bunch of things you can do to kind of like maximize performance, like the elastic fabric adapter, which is this crazy fiber adapter you can put on the back end of your virtual machines. You can put things in placement groups. You can enhance networking. And that's really actually what we're going to be talking about is really just that whole networking tier right there as far as placement groups go. Fabric adapters and enhanced networking. So here's what you need to know. If you just run the standard network interface, you're going to get up to 10 gigabits of throughput if the virtual machine supports it. This is the default. Now, I say up to 10 gigabytes. If you're using a T3 series, you're only going to get up to 5 gigabits. If you do something, you know what I mean? It's like, it depends on the size of the machine, whether or not you're going to get 10 gigabits or not. There are other machines that you can get that have ENAs. So notice the top, instead of an ENI, you have an elastic network adapter. Those will go up to 100 gigabits per second. They are an optional thing that are only on certain types of EBS instances. Which ones? Well, you know, we all got to read the documentation for that. But like your I series and whatnot, those will support it, right? So, and then last but not least, and fastest, is that you can get up to 400 gigabits a second. This completely bypasses the OS, by the way. It's almost like its own independent little operating system ready to operate on your network. But this one, by the way, will support, again, on supported instance types, up to 400 gigabits a second. And this is the elastic fabric adapter, and that's what's in the upper right-hand side. So just know you have options beyond just the basic ENI to add an ENA, a network adapter, or add an EFA, which is a fabric adapter, to increase the speed of your systems. But make sure you read the documentation because EFAs and ENAs are only supported on certain types of instances. So you got to find out if you've launched that type or you got to launch it, okay? 400 gigabits a second, that's a lot. That's really, I mean, I think 100 gigabits a second is a lot, but you know, 10 years from now, we'll be like, oh my God, back in my day, we had to run 400 gigabits a second, you know, something like that. All right, now let's talk about placement groups. So we just talked about fabric adapters, and network adapters, and network interfaces. Let's talk about placement groups. So this is what I was talking about earlier, where you're trying to place machines on the same physical host, or you don't want performance, you're more concerned about availability, and you want to make sure that none of the virtual machines are ever running on the same hosts. Or you've got clusters of databases and you want those running on different hosts, but you want them to run on the same host in different data centers. So there's 3 different scenarios where you're like, I want them all apart, I want them all together, I want them to split, and I want them all together in whatever region they're in or whatever availability zone they're in. So it gets really kind of weird. So without placement groups, EC2 instances are typically not placed like near each other, right? By default, Amazon's going to try and keep your workload spread across virtual machines. They typically don't like run all of your workloads on the same box because they don't want you to lose it, right? And so they typically try to do it almost like a spread placement. With placement groups, you can actually tell Amazon explicitly this workload has to run on the same box, it cannot run on the same box, or these 3 need to run on this box and they need to run separate from these 3 which can run on this box. So you've got like different controls that you can implement here. So for example, here's a cluster placement group which says, hey, by the way, run everything on one physical machine. I want all of my virtual machines to run on the same box in the same availability zone. Does anyone want to say, does this increase or decrease resiliency and high availability? Good. I'm glad you're paying attention. It definitely decreases, right? All right, now then that was a cluster placement group. So cluster, 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 that was the cluster placement group. This is a spread placement group. Notice what they're doing here. Does this increase or decrease high availability and resiliency? Okay. And then what we have is called a partition placement group. Now, this decreases resiliency, but it decreases zone resiliency, like regional resiliency, but it increases host resiliency, right? So in this particular case, you're not isolated to a single host, which is kind of horrible. But at least if you lose one host, you get the other 2 hosts up. If you lose the availability zone, well, you're done, right? This is called a partition placement group. So if you need the highest network performance possible, you have to use a cluster. If you want the highest like resiliency and high availability, you need to use a spread group. If you're like, I'm okay if I lose an availability zone, but I need to like spread everything out so that if I lose a single host, I'm not going to lose all my database systems. But I want to keep them close because there's some data replication going on, like you're using Cassandra, for example, then you're going to use partition groups, right? And partition groups, as a reminder, look like this. Same AZ, but you're spread to different hosts inside the AZ. Okay? This, by the way, is really for partition-aware applications like Apache's HBase, HDFS, like the Hadoop file system, Cassandra, right? Things that are aware that they are being partitioned out into clusters. Questions about placement groups of any type? Okay, let's talk about serverless. All right, serverless. All right, so we're moving out of virtual machines at this point. So we're no longer talking about virtual machines. We're no longer talking about Windows, Linux, or Mac OS. We are now talking about the highest abstraction layer, which is serverless, which means that what's happening now is that you can now run code and somebody else manages the servers for you. So you don't care about the operating system. All you care is, does it have the JVM, the Python interpret, does it have the runtime that you need? You upload your code and they take care of it for you. This is what Lambda does for you in AWS. So they take care of capacity provisioning, scaling, all the server and OS monitoring and patching, all of that's done for you. Node, Java, C#, Python, Go, Ruby. Oh, it's right there actually in PowerShell, right? And then you can create custom runtimes for things like PHP and Rust, other things, right? You can only run a single execution for 15 minutes, but that doesn't mean you can't call another execution at minute 14 and then call another execution at minute 14. So you can chain executions together if you want to. This does, I think it says 10 gigs of memory. I thought that had gone up actually. Let's roll with that for the time being. So let's say it supports up to 10 gigs of memory. When you create a Lambda function, the main thing you have to do is you have to tell it how much memory you want, and then what do you want its triggers to be? What do you want to actually trigger this thing into running, right? And so that could be, by the way, someone uploading a video file to an S3 bucket. It could be the deletion of an EC2 instance. It could be the start of an EC2 instance. Pretty much, especially with CloudWatch events and AWS config, you can trigger pretty much off of anything that happens inside of AWS. You can trigger a Lambda function. So all those one-off scripts that you used to write in Bash or Python or Perl or whatever that used to run in your environment in the response to events happening, guess what? You don't need a cron system anymore. You can actually get Lambda to do it for you. You don't need to run your own server. And by the way, if this thing isn't running, they charge you by the millisecond. If it's not running, you don't pay anything. So if you run this twice a day at 5 minutes, you're going to pay for 5 minutes of compute. You don't pay anything else. So this is ideal because it literally doesn't do anything until it needs to be triggered. You don't get paid. You don't have to pay for this at all. It just sits there. Even the monitoring doesn't cost you anything, right? What can trigger Lambda? I'm just going to tell you, pretty much anything can trigger Lambda, right? You could have somebody watching your AWS infrastructure and it could call Lambda. You can use CloudWatch events, or also known as Event Bridge. You could use AWS config. You could have CloudWatch trigger an alarm, which calls a Lambda. You could have, the world is your oyster here, to use a phrase. Anything can trigger Lambda. You just have to find the way to get it to trigger, right? But for the most part, Event Bridge, CloudWatch events, or AWS config are going to be your main triggers. By the way, what can you use this for? Some people run their whole websites off of this, chatbots. You can hook it into an Alexa skill if you want to, data processing backends. You can do all kinds of stuff. Here, by the way, is a simulated slot machine browser game, right? It's just a Lambda function. So when you load up into the website, it has client-side JavaScript. It just calls a Lambda function, which then randomizes. In this case, it returns, I guess, the random cherry, puppy, and robot images. Yeah. This is using the SDK for JavaScript, by the way. That's it. That's all you need to know about Lambda. You upload your code, you answer a few questions, you set a trigger, and you let it run. By the way, if you want to put it on a schedule, you can have it run at the top of every hour. If you wanted to have it triggered based on some events, you just put your trigger events in there, and that's it. Make it sound really simple. We're going to mess around with that a little bit more. But that's it for Lambda. That's all you need. And if you need to orchestrate a whole bunch of Lambdas together, they have a thing called step functions that allows you to create a workflow that allows you to do what is becoming increasingly popular, which is called event-driven architecture, meaning an action triggers another action, which triggers another action, which just is event-driven, right? All these events trigger some kind of code response, but it's no longer one big application. It's just a series of functions that get triggered when an event happens. Like someone opens up a firewall to the world, which triggers a Lambda function, which closes that firewall down, right? Or someone does a malicious recon and that shows up in guard duty, and then that triggers a notification and a response where all of a sudden that IP address is blocked in the NACLs. These are all real examples, by the way, of how we use Lambda functions to trigger security responses when people mess up. I say mess up. We all mess up. So, it's just human nature. Questions of any type before we do a little knowledge check. And then we're going to take a break. All right. Which of the following are true for Amazon machine images, for these golden images, right? What can we specify here? Remember, the AMI specifies questions about the virtual machine. So AMIs do not specify subnets. You actually have to specify that at the time that you invoke the AMI, right? So that's accurate. So I'm glad, right, that you avoided A. AMIs can only be obtained from the marketplace. We know that's false because you can obtain them. You can make your own AMIs if you want to. AMIs can only be used by users within a single account. No, that's weird because you can actually publish them out to the entire world if you want to. Don't use, by the way, an unknown stranger's AMIs. You have no idea what's in that AMI. So then B, AMIs can include block device mappings like EBS mappings that specifies the disk drives that are attached to the EC2 instance when it's launched. That's true. And then D, you can launch multiple instances from a single AMI. That is the whole purpose of AMIs, is to do repeatable, consistent launches. So B and D are definitely accurate. So good job, everybody. All right. All right, next question. In the instance type named M6G2X large, which part of that name indicates the instance family and helps determine what it's designed for, like what its best use case is for? Is it the M, the 6, the G, or the 2X large? Good. What did I say that M stands for? It doesn't stand for memory. What does it stand for? What does the M stand for? Because R is RAM for memory. I said M was blank for general purpose. That's just my made-up mnemonic, by the way. It's median. It's a general purpose machine. It's an average machine. It just sits right there in the median. It's not fast on processor. It's not high on memory. It's not great with disk. It's median. It's in the middle, right? So M for median. This is a general purpose family, right? Good. Good on the answers, by the way. Which of the following are true statements regarding Lambda? Whew, those should stand right out. All right, so not A. Jorge, I see that. Okay. Functions can run for a maximum of 15 minutes. Yes. Right. And then functions can be allocated up to 10 gigabytes of memory. That's correct. Right. You are not responsible for the servers for Lambda. It does not only support Python. And functions don't require a security group. Right. Yeah. They don't require a security group. You have to put a role on Lambda functions for them to function. Remember roles from users, groups, and roles from IAM? You have to grant permissions to both invoke a Lambda function, and you have to have permissions about what a Lambda function can do once it's invoked. So there's actually two sets of permissions for a Lambda function. Who can tell it to go, and what can it do when it does go, right? All right. Yeah, don't worry, Calvin. When we do the exam practice later on today, I'm going to make sure I emphasize the keyword analysis for the questions when you get them in the exam. All right, that's the end of Module 4. It is currently 10:50, And we did our lab for this yesterday. You may remember us doing VPC infrastructure. So we did our lab for this yesterday. Anybody have any questions they want to ask before we take a quick 10-minute break? Okay, reminder that we're taking lunch at 12:30. So it's 10:52 now. So let's come back at 11:05. So we'll give you a 13-minute break. So take a 13-minute break, 11:05, and then we're going to move on to storage. So we're going to talk a little bit more about storage options. Okay. All right, we'll see you in a bit. Anything that we want to talk about? Do you feel like you're getting a massive amount of information? Just want to make sure that you feel like you're getting a download here, right? Because if you weren't getting anything, it seems like that would be a waste of time. Well, notice I didn't say recall, so I'm not expecting anyone to just pop out and say, hey, I've totally got this, Forrester. All right. Cool. Good. Good. Excellent. Okay. And a reminder that once we take our first lab, or maybe even over lunch, I do have recordings of all this. It will be shared with you, so you can always re-review at some point. Just note, by the way, if you take an official class with AWS, they do not record their sessions, so don't expect that from them if you ever take another course with them. Okay. Let me put my dangerous liquids away from my computer. Give me just 1 second. Good. Thanks for the feedback. Appreciate that. All right, so another weird check-in. Are these check-in questions weird, or is it just me? Because I feel like most of us don't know the answer to these questions, especially if we work for an enterprise. Not all of us are like, I don't know what you would call that, enterprise architects or overseers of everything around cloud inside of an environment. So which statements are true regarding block and object storage? So actually, this is a good question. Which of these statements are actually true here? What's the difference between block and object storage? No one? No guesses here? All right, so here's the difference, actually, assuming that I can stop messing with the screen. So block storage actually does use a file system hierarchy. So when someone presents a disk to you, you have to write a file system on there. In other words, the operating system needs to know how to manage the disk. And the reason for that is that block storage is attached to operating systems. So when you plug in a USB hard drive, Al, you are plugging in block storage into your system, and that storage is going to get read by the operating system. In order for it to manage that disk, it lays out a structured file system, and it breaks the disk into blocks. When it writes a file, it uses one or more of those blocks to write it out. Block sizes, by the way, can vary. You can have them to be like 1K, 4K, 8K, like Amazon, I think, uses like 256K or something like that. But like block storage is when you attach it to the operating system and the operating system manages it. Block storage, by the way, if you update a file and it's using 4 blocks, but you updated the end of the file, it's only going to update the last block. It's not going to update the other 3 blocks. It doesn't need to. Nothing changed. So block storage tends to be faster and more efficient with its updates. Object storage is not mounted inside of an operating system. This is a remote storage system. Think of this as like FTP, right? Except the difference is that you're not using the file transfer protocol. You're using an API call, and you're giving the entire file to the system. You are dumping the entire Word document. If you make a change to that Word document, you have to re-upload the entire document. because it's not storing it as separate little discrete pieces. It's storing it as one big chunk. That's object storage. So it's going to rewrite the entire file upon updating, typically. So it's really all of the above in this case. Now, here's where things get weird and confusing, because if there's one thing that we're good at as human beings, we're really good at making things complicated. If you're not seeing that, I've seen it. Block storage is when you add a hard drive directly to your operating system. Now, I say that, it's so weird. Amazon actually runs EBS across the network, but it uses a protocol that makes it look like it's connected directly to the operating system at a low level. So block storage is like hooking a USB drive up to your system. File storage is like you've got a server sitting off in a corner somewhere, and it's presenting its hard drive to your operating system. That operates at a high level, and that's called file storage. We're used to that because it shows up as a drive later if you're using Windows, or it's part of the file system if you're using Linux. And this is basically used, it's the best way to say it. It's like a network drive, right? It's just being shared across the network, but it's not using the low-level protocol that block storage is using, so it's not as fast, but you can reach a lot more systems because it is a network-based share. Block storage is kind of a network-based share, but it needs really strong networking to go that fast. And so file storage and block storage both mount inside of an operating system, but the difference is that block storage is way faster and file storage is more distributed. Now, object storage is not as fast as file storage and is not as fast as block storage, but it is even more distributed than any of the other two options, which means that object storage is a great place to just dump large numbers of files. So Ceph, Rook, OpenStack, Swift, S3, Azure Blob, right? This is where you're actually just uploading an object in a sense to a database, right? Now you can't see the database. It doesn't operate like a traditional database, but that's really what an object storage is, right? Now Amazon offers all three types. Yeehaw, because I know you were so worried. You were like, how does Amazon stay competitive if they don't offer object storage? I know you were so concerned about that. So here's the kind of like business need that we're trying to solve, right? One, the data centers are running out of physical storage. Storage is always a problem in a physical data center. You're always running into that hardware boundary, probably even more than compute. Second problem is that you need to share a web-enabled file system across 1,000 hosts. How do you do that? Third problem is that we are having to dump data repeatedly. We have all these log files that we're capturing for security purposes, and we've got these analytics that we're collecting for machine learning purposes. I need a massive data dump that is secure, that I can dump all these files into, that nobody can get to. I also need a data lake that I can actually dump tons of these analytics files into that the machine learning folks can get to as well. Now I have to secure both of them. In addition, what if I need to transport petabytes of data and my network is not fast enough? I cannot saturate my network by doing that. How do I solve those problems? And so that's what we're going to do, is we're going to talk about the options for both transporting data offline up to Amazon from your data center. We're going to talk about how you can use block storage, object storage, and other storage facilities to transfer data up to AWS. How do we do that? All right, so in our architecture, I want you to note the two green sections. So S3 in the lower left-hand side is one thing we're talking about. We've already talked about hard drives, right? EBS, instant storage, remember that whole discussion? And then now we're talking about EFS, which is file storage. Now, EFS has a Windows-based cousin called FSX. So EFS is really for Linux, and it uses NFS. FSX for Windows Server is SMB for Windows. Now, I'm going to forewarn you, because man, Amazon's weird sometimes about this stuff. FSX also has 3 other flavors called FSX for Lustre, FSX for ONTAP, and FSX for OpenZFS. If you are a Linux person, you probably know what those are. If you're not a Linux person, you don't care because you've never had to use them. But just know that FSX for Windows is one of 4 subproducts that the FSX has, and all it does is it presents specialized file systems. I wish they would just name it all the same thing. So EFS is for Linux, and that's used as NFS. FSX for Windows is for Windows, okay? So that's what we're really talking about, which we're talking about S3, and it's like 6 storage classes. And we're talking about EFS and FSX with its 2 different flavors. We're not talking about all the flavors of FSX, just the flavors that apply to Linux and Windows, okay? All right, so first, let's talk about the various storage services. Let's just talk about what our options are, right? Did you ever feel like you had something important and then you lost it? There we go. Okay, so first of all, just know that when it comes to moving data, hosting data, and securing and managing data, AWS has a ridiculous number of options. Whether it's, and this doesn't even list everything actually, because there's like data sync and data pipeline and data center migration services, server migration services, database migration services, direct connect, data sync. There's just so many options for moving data. But hosting data pretty much sits in the center. So look at that purple little thing there. So block storage is EBS. File storage is EFS and FSX, which I was just talking about. And then S3 and then Glacier, which is a flavor of S3, really. That all sits in object storage. Notice also on the lower left-hand side, it says the Snow family. So we're going to talk about the Snowball and the Snowmobile. Who names these things? So the Snowball and the Snowmobile we're going to talk about because they're useful, but they also have funny names, so we have to talk about them. So let's first talk about object storage. So let's just talk about this piece first, okay? So object storage, which is different from block storage, because we've already talked about block storage. We're not going to talk about that again. S3, right, is the object storage system. I used to joke, and I think this may be insensitive to people who struggle with addiction, but I used to joke that this was like the gateway drug, right, of Amazon. And you know, I don't know of a better way to say that, but this is the service that teases you in to Amazon, because it's like once you start using S3, the next thing you know, you're rolling out virtual machines and you're using databases, right? It's just like what just happened? And the problem is that S3 is ridiculously easy to use. You create a bucket, you upload files to that bucket, and then you share with your friends. It's a little bit like using Dropbox or Box, except this is enterprise class storage. So for $23 a month, you can get a terabyte of storage, and it's like super redundant and super performant. Now, what do you use S3 for then, Michael, now that you've made your inappropriate joke, right? Is that really S3 is actually used for anything where you want to you just want to dump a bunch of files. You want to dump a bunch of log files? Great. Images, video files. Like if you just want to dump a bunch of files out there and have them shared with either internal people, or if you even want to share stuff out on the internet, because you could have a bunch of video files that you are managing and you want to share out with people across the internet in a controlled way, because I don't want you to show up in the news because you shared a bunch of credit card information, right? This is what S3 is used for. It is literally a file dump, and the minute you dump a file in there, if you want to, you can get a URL to get to that file. It's actually created for you automatically, but you have to open up your firewalls in order for that to happen. This concept, you can see the URL down there, right? Is that first thing you do is you create a bucket. Now, buckets have to be named. They have to be globally unique across all of Amazon. So you can't call it, you know, my new bucket, because someone out there is using my new bucket, right? In this case, like you couldn't use doc either. There's no way you could use doc. Someone's got doc, right? It's like domain names, right? Someone's got the bucket name you're looking for, so you're going to have to get a little creative or throw some alphanumerics in there. Now notice in this case, when you upload an object, in this case it was the Amazon S3 HTML file, they put it under a folder, which is also known as a prefix, called 2006-03-01. So that whole thing represents that object, that prefix plus the object itself. And that whole thing, it looks like a folder. It's not really a folder. It's just a label. It's a prefix label. But they present it as a folder so our brains don't melt down when we're navigating it, right? And then the bucket, which is a little slid a little to the left, should be underneath doc. So the bucket's called doc. Let me give you another example of this so we can drive this home. If you're out here messing with S3, right? And let's say, like I've got a bucket out here called BAH admins, right? Nothing super sensitive or proprietary in here. And see how this presentation is right here? If I click on this presentation object, I just want to note that like the bucket is BAH admins. Then the S3, US East 2, Amazon AWS, et cetera, that's all like just standard URL suffix. And then the objects listed right here, 2021, 1028 plus presentation, because I put a space in there probably, zip. And that URL, well, if my firewalls are open, which I think for this case they are actually, because there's nothing like super secret or proprietary in here, this will actually allow you to download the thing in question. Notice it also has an S3 URL, which is used when you have to interact with it, like just from an S3 perspective. But this is the URL that I can share with the world if I wanted to. So that whole URL forms the key. Now there is a generic URL that doesn't use the USS, the region name for the buckets. Note that S3 is a regional service that's managed globally. So your buckets have to live in one of the regions inside of AWS, okay? So they have to have a home, like US East 2 or US East 1 or US West 2, whatever. EU Central 1, doesn't matter where it's at, but you have to put it somewhere. Access controlled, so just to say this, access control is controlled by both identity-based policies, but also is controlled by resource-based policies. Remember, S3 is one of the few services that has resource-based policies. We talked about this before. This is where the policy is applied to the service, and the service can control who gets access to it. SNS and SQS, which I showed you before, also have the same thing. Now, by default, because Amazon kept showing up in the news, because customers kept opening up their buckets and allowing hackers to download whatever they wanted, they enabled this firewall called block public access. In order for you to enable anybody to get access to your bucket, you have to disable this, and then you have to add a bucket policy that specifies that anybody can get to your bucket. So just know that you have to go through at least a two-step process. And as you may have noticed, Amazon's going to let you know the entire time that your bucket is open to the world. Hey, by the way, guess what? There's a little sign here that says publicly accessible. Hey, guess what? Guess which one of these buckets is publicly accessible? So when people show up in the news because they've misconfigured their S3 buckets, that's not Amazon's fault. I'm just going to say this. They have really done everything they can to make sure that people know, hey, are you sure you want to put that credit card information right there? Because that bucket's public. So they even warn you on the command line, by the way. So you know, hey, you just uploaded that to a public bucket. Thanks for telling me. Now, the other thing you can do with these buckets, which are amazing, is you can run websites in out of S3 buckets. You can turn on versioning, which, by the way, means it's going to make a copy of every single version that you have of a file, which is fun and can get expensive if it's a 100 gigabyte file. Just be aware of that, right? And by the way, when you delete a file that's versioned, you don't actually delete it. It just like puts up a delete marker. If you actually want to delete a file where versioning is enabled, you actually have to go in and explicitly delete every version of the file, including the delete marker, just FYI. Just like Glacier, if you need to lock this bucket so anything written in here is read many times but written once, also known as worm, write once, read many, right? You can lock this bucket so that anything written in here can only be read. It can't be changed. right? You can object lock it. There's different flavors of object locking, right? But this will prevent anybody from overwriting or deleting your file if you want to. Now, S3, even though it's not block storage and it's not file storage and it is object storage, even though S3 is object storage, it does actually have tiers of performance. And these tiers of performance range from super hot to super cold, which is why, by the way, the coldest is called Glacier and Glacier Deep Archive. Now, notice there's S3 standard and intelligent tiering, and those are the hottest flavors of S3. Standard infrequent access and one zone infrequent access are for files that you still want to be accessible, but you want them to only be infrequently accessible. And once you step something down from infrequent access into Glacier, you cannot access that file directly until it's restored. So think of Glacier as a vault, because that's actually what they use, is they use vaults. When you say, hey, I want to stick this file into Glacier, you're saying I don't want that file to be accessible unless I restore it from Glacier back into S3. So back into one zone or back into standard S3, okay? So just know that once it's in Glacier, it's no longer directly accessible. So if they ask you a question and say someone wants to put a file into infrequently accessed storage, the answer is not Glacier. If it's being infrequently accessed, it's still being accessed. If you put it into Glacier, it's no longer accessible. So Glacier is for archiving data. It is not for things that you're going to access even semi-regularly. So let's make sure that's super clear, because that will pop up on the certification exam, is that Glacier is for stuff that is being locked away. If you still want it accessible, use any of the other 4 storage tiers: one zone infrequent access, standard infrequent access, intelligent tiering, or S3 standard. Glacier is S3's colder version, right? Super cheap, by the way, usually 1/10 to 1/20th of the cost of standard S3. By the way, all of this has 11 nines of durability. It's not just Glacier, everybody, which means it's going to take them 100 years to lose one of your 10,000 files. It's something ridiculous. Now, when you put things in Glacier, since it goes in a vault, you have 3 retrieval options you can use. You can pay a little bit of money and get expedited retrieval. You can pay a very small amount of money and get standard retrieval, which is going to take 3 to 5 hours. Or you can pay no money and use bulk retrieval, which is going to take 5 to 12 hours to restore your file. Remember, these files are not accessible if you put them in Glacier. If they're in standard S3 or in frequent access S3, they are accessible. By the way, all data in Glacier is encrypted by default, so the minute you stick it in Glacier, it's encrypted. You can put object locking into Glacier as well, so all of these tiers can have object locks enabled for them. Hey, there's some vaults. So you take an archive, you stick it in a vault, you can lock a vault if you want to, right? Vaults can be locked indefinitely. They can be locked for a period of time. You can make it so that no one can undo a lock, or you can make it so that admins can undo a lock. Archives are grouped together. I think the maximum file size for S3 is 5 terabytes. The maximum file size for Glacier is 20 terabytes. So a single file can be 20 terabytes in size. Make sure you've got some good consistency checking if you decide to make a 20 terabyte file. Yeah, you know what I mean. This is the thing I was talking about earlier as far as retrieval times. Expedited is going to cost you 0.03 cents per gigabyte of file that you retrieve. That's going to restore your file in 1 to 5 minutes. Standard is going to be 0.01 cents per gigabyte. It's going to retrieve you in 3 to 5 hours. Means the file's not going to show up for at least 3 hours. And then batch access is free, 5 to 12 hours. But that's when you're going to do a bunch of files at one time. There's also a new one that just got announced 2 weeks ago called Instance. I think it's 5 cents per gigabyte. But you can instantly restore a file. That is for the most urgent level, and you pay 5 cents a gigabyte for that. So plan accordingly. With all of S3, whether it's standard infrequent access, intelligent tiering, or Glacier, you can actually set lifecycle policies that said, hey, if you are older than 30 days, move down to infrequent access. If you're older than 90 days, I want you to move down to Glacier. If you haven't been accessed in 120 days, just move down to Deep Archive, right? Excuse me. So there are 3 types of encryption: server-side encryption that the system supports. It supports native S3. You can use the key management service, or you can submit your own customer managed keys and let KMS manage those keys for you. There's also a 4th option, which is called client-side encryption, CSE, not SSE. So just know, and this figures on the exam, by the way, they want you to know that you can actually do customer managed keys where you actually submit that for server-side encryption. You can let KMS manage the keys, or you can let S3 manage the key. So there are little differences between them, but basically this is how you encrypt data. When you do this, by the way, what happens is that there's a data key that gets encrypted by this master key, which is why they're talking about customer managed keys, right? And that key, that encrypted data key, not the master, not the primary key, but the like data key is encrypted and then stored with the data. But it's stored encrypted. So the only way for you to get that key undone is to actually be able to talk to the primary key in your account. That's where KMS comes in, by the way, or S3. They do that for you. If you do C, customer managed keys, you have the key. So if you lose it, you lose your data. Just FYI. You lose an encryption key, your data's gone. At least until quantum computing hits its 20-year stride. Okay? That's kind of a joke, by the way, but that's probably true. You can, by the way, in addition to encryption at rest, by the way, everything with Amazon is going to be encrypted over the wire, right? So just know that if you send things using the SDK or the command line, it's going to be encrypted by default. So, Kyle, I didn't know that Booz had a paper on S3 encryption. That's cool. I'm going to see that at some point. By the way, you can replicate objects in buckets both inside of a region and to other regions. So you can replicate from bucket to bucket inside of a region. You can replicate from bucket to bucket in another region. So if you've got, hey, I'm going to put all my database backups inside of a certain like S3 bucket, you can then replicate that bucket to another region for restoration. So just know, right, is that you can't actually do what's called cross-region or intra-region replication. You can also get S3 to kick off Lambda events like, hey, by the way, tell Lambda that I just uploaded a video file. And then you can get Lambda like to update the meta information about the file in a DynamoDB thing and then kick it back, maybe an output file of some type back to another S3 bucket, right? So just know that S3 can, once it triggers Lambda, you can get to any service, right? At that point, once Lambda is involved, Lambda can invoke any API. So you can invoke any service you want once you get to Lambda. So just know that S3 can trigger events. Now, S3 has a number of options that will help speed up your ability to upload files across the entire world. So it's not just, CloudFront, by the way, most people think of CloudFront as being really great at speeding up downloads. But CloudFront, as you can see in the bottom, will actually intercept someone's uploading a file, and then you can use Amazon's backbone to upload to S3. So this is called transfer acceleration. And you can use this if you want to speed up your transfer of files from, like, let's say you're in, Russia and you're trying to get to a server in the United States. Instead of going all the way over to Virginia, as an example, you could actually go to a server over in China, hit that server, and then go over Amazon's high-speed backbone to hit the system in Virginia. So Amazon does this because this actually speeds up the upload of files. In addition to actually just speeding it up by putting you on a faster path, which is what this does, it puts you on a faster internet pipe. Now, know that you're still going to be capped by the speed you have on your internet pipe, right? But what you can also do is you can also break it up into multiple parts. Now, if you don't have extra bandwidth on your pipe, this isn't going to solve anything for you. But if you can't use the full bandwidth because you're limited to like 2 megabits per second for a single connection, you can actually go to a multi-part upload, get 8 megabits or 10 megabits or whatever per connection, because maybe you have QoS on like quality of service restrictions on your network for whatever reason. This will allow you then to create multiple separate connections for uploading, right? So does everybody need this? You might want to experiment and see if it makes a difference, but it also depends on how your network is set up. But just know that Amazon's general recommendation is that if you're using their SDK or their command line, and I think if you try to upload a file that's more than 100 megabytes, it's recommended for 100 megabytes. I think if it's over a gig in size, Amazon's going to force you to use multi-part upload for, I think if it's a gig in size. So you just really need to know that transfer acceleration and multi-part uploads exist to help speed up your upload progress. This does show up on the exam. By the way, if you upload 3 parts of a 4-part file, Amazon's going to hold on to those 3 parts until you upload the 4th. Once it gets all of the parts of a file, it'll then reassemble them and put them in the S3, which is actually pretty cool. But don't forget, if you keep doing abortive multi-part uploads, you could end up with pieces of a file eating up storage in your account, and you can't even see it. You actually have to go to the API and actually take a look at it and realize that you've probably tried to upload this file 15 times and you forgot to complete the 4th part in every single instance. So you've got all these little bits and pieces of file just sitting out there in S3 where you can't see them in the console, but you can see them on the API. Okay? So, oh, by the way, this also allows you to write a file that like where you have the first couple of parts, but you don't have all the parts. And so like you could like be writing a file down. You've got the first 4 parts. It's going to do the first 4, and you're writing the next 8 and the next 8 and the next 8. So it does actually allow you to, in a sense, like kind of like a stream of file that's still being written to disk. It's just kind of cool, actually. Amazon came out, so they ran into a problem, by the way. I don't know who ran into this, but the access policies got too large for a single bucket. So what Amazon did is they came up with aliases, which you could actually have different names and different entry points to a backend bucket. So for example, it says my bucket there, but then let's say it's finance.mybucket.s3 or accounting.mybucket or sales.mybucket. So they came out with these aliases that you could actually attach access policies to, and they're actually all pointing into this backend bucket. So think of access points as aliases that have their own independent security policies that you can actually make for different like groups or different use cases. So, you can't, for example, modify the bucket. You can only actually perform on the objects inside of a bucket. If you want to manipulate the bucket, you've actually got to go directly to the bucket. But if you want to see all the objects and control, like put aliases for all the objects that are inside of a bucket, you can actually use these access points to create aliases, right? Now, Amazon also has the ability with S3, because I got to tell you, S3 is a plethora of features, right? With S3, you can actually add your own code so that if someone tries to pull personally identifiable information off of an S3 bucket, you can actually have a Lambda function that will actually strip out all the credit card information if someone tries to pull it off of the bucket. So you can actually have these redaction functions from Lambda that will protect your data if someone tries to pull it, right? So you can make it so that it scans the data. If it sees, like, for example, something matching credit cards or social security numbers or birth dates, it'll actually like replace it with ones and whatever you want to replace it with, right? So you can also convert data on the fly, add data, decompress, like you can do all kinds of stuff, right? With this Lambda object Lambda. So now here's some cost factors around S3. First of all, it matters which storage tier you use. Hot storage is more expensive than cold storage. How much data you put in here makes a difference. So 1 terabyte versus 20 terabytes, you're obviously going to pay more. If you pull stuff out of S3 for use across the internet, you're going to pay money for that. If you pull it out to go to CloudFront, you don't pay anything for that because Amazon doesn't charge you for pulling data out to use their services. If you pull it out for an EC2 instance that's in the same region as the bucket, you don't pay for it, right? But if you transfer it out for any other reason, including going from US East 1 in Virginia to an EC2 instance that's in Oregon, you're going to pay for that, right? So if it's in the same region, you don't pay for it, or if it's CloudFront, it doesn't matter. But if you pull it out of that system for any other reason, or it's coming from another region, then you're going to pay for it, okay? So you don't have to pay if you upload files, and you do not have to pay if you're using CloudFront or if the EC2 instance is calling it from the same region. So here's some best practices to think about as well, right? First of all, make sure you understand that if you need to protect your data, you can turn on things like MFA delete, versioning, you can do replication. For security purposes, you can do access points, which are aliases. You can enforce object ownership. You can turn on encryption. You can block public access. You can control the firewalls. If you need to move between data tiers for pricing purposes, make sure that you're either using lifecycle rules, and if you don't know your access patterns for S3, then you have to use intelligent tiering, because intelligent tiering will move your files between all the storage classes for you if you don't know what your access pattern is. So again, the use case for S3 is this. This is object storage. It is for a massive dump of files across an entire system, and you don't want to put it on a hard drive, and you don't need it to be particularly fast, right? If you want to mount this inside of an operating system, you can't. And I say that someone wrote a program where you could, but this thing performs horribly inside of an operating system. This is an external system that you call to dump files and retrieve files. That's all it's for, okay? Okay. It's very easy for us to bind on patching, so we're now moving over to shared file systems. Does anyone have any questions at all about the storage pieces that we just talked about? By the way, this is one of the longest modules in our entire set, so if you're kind of like, Michael, man, this is a lot of information. It is, because this is the longest one. Okay. All right, so let's talk about EFS then. Okay, so shared file systems. Talked about this already. EFS is different from object storage because this is not S3. This is file storage, which means you've got a server that is serving out a file system across multiple mount targets in every single availability zone in the region. So here's the key difference, by the way, between this and EBS. EBS, the hard drives only run in one availability zone. So you can only mount that disk drive if you're in US East 1A or US East 1B. Like, the drive only exists in one availability zone. With EFS, you actually can present a file system, not a disk, but a file system across an entire region. So notice here that we've got mount targets that are hooked back to this EFS server. And what happens is that the servers that are in those respective VPCs or respective availability zones, they just mount that mount target. That's it. This runs across regions, by the way, and this is the only one, the file system that will do that, is EFS. Now, EFS is used when you want to actually have a big file system shared across hundreds or thousands or 10,000 servers all at the same time, and you want them to be able to read and write against that system at the same time, right? So this is a shared file system. That's what it is. So notice here that you've got EFS standard and EFS one zone, which most people don't know about. It can auto scale up and down performance wise. So it's not like a disk drive where you've got like a maximum cap. It does have a cap, but it's super high, right? And so this is a user defined throughput. It's got 4 nines of availability. And by the way, this will also do snapshots. It'll do all, yeah, it's got some really good features that aren't really talked about a whole lot, but it's got a lot of the features that EBS has actually. When you set it up, you actually specify which availability zones you want it to be available in by specifying mount targets in those AZs. Then you get a DNS name and or a file system ID. And what will happen is that you can then mount that inside of an NFS capable operating system, which is mainly Linux. Although you can get Windows to mount NFS, right? These mount targets, by the way, are not single points of failure. These are virtual devices, just like an internet gateway, just like an, not a NAT gateway, but like an egress-only internet gateway. They're not really single point devices. It's actually just an endpoint. There's actually multiple virtual devices in there. So you don't have single points of failure with this, or bottlenecks typically. So that's EFS. FSX is the Windows version of EFS. Now, this, by the way, comes, like I said, I think there's like 4 flavors now. So there's FSX for ONTAP, which is a NetApp file system. There's FSX for OpenZFS, which is a really popular flexible file system, right? So this is a POSIX compliant, just like EFS is POSIX compliant. This is a POSIX compliant file system. It does integrate, by the way, with S3. And I'm talking specifically about Lustre. The Windows file server is just a Windows file server. That's all it is, right? It does do like data deduplication and will hook into Active Directory. I want to say, I don't think this is actually cross. Oh, I stand corrected. They just updated it. So what happens here is that apparently you can actually run across availability zones. Notice it's actually connecting to a Microsoft Active Directory server. I didn't know if they were actually going to put this in the slides, but because it just recently got like cross AZ capability, right? This, by the way, has native capability back to Windows 7. It's basically SMB version 3. So all the patching and maintenance is all handled by them, by the way, because you don't actually see the servers. It does integrate with Active Directory. It does use DFS, so if you're using the distributed file system, you can do that. So, and it's Windows NTFS, so it's the NTFS file system by default. Now, Lustre, which is a slightly different flavor, this is used for HPC computing. So this can, by the way, can process massive data sets at gigabytes per second. So this is for a really high throughput shared file system that's used for a high performance computing cluster, okay? So this is really a specialized use case for when you're running an HPC cluster, right? A high performance computing cluster. That's what it's used for. Yeah, funky thing is about Lustre, which kind of cracks me up, is that it will write to S3 as if it's part of the file system. Now that's not going to be fast, just so we're clear. But you can write to a directory inside the Lustre file system, and it actually is writing to an S3 bucket. Again, not lightning fast, but makes it easy for you to output processing returns to S3, right? So remember, EFS is basically NFS for Linux. FSX for Windows is for Windows systems. And then FSX for Lustre is just a high performance computing file system. That's all it is. So just remember that. The ONTAP and the OpenZFS thing, that's just trivia. Just let that go, right? All right. Any questions about EFS or NFS? Okay. Reminder that we're going to go to lunch at 12:30. So we're going to get through this, maybe do a little bit of database. When you come back, we're going to finish up the database section, and then we're going to roll into some labs, okay? So just know, we won't be doing labs until this afternoon, but we will actually be doing labs today. So bear with me just one second. Let's see, Kyle. So was EFS region specific or multi-region? Nothing is multi-region as far as the file systems go. So EFS is, single region, but you can actually create replication, like take a snapshot and copy it over to another EFS system. But EFS instances are single region for the most part. Let's see, Mac OS uses, is it object storage? So Mark, you know, Apple has its own proprietary file system, but Apple doesn't play in the enterprise space. They don't provide enterprise tools because they're not interested in that. So typically what happens is that they'll either mount a Windows file share or they'll mount a Linux file share. You can actually add the capability to do both with a Mac OS system. Good. Okay. Looks like I answered the questions to make sure I didn't miss anything. Cool. All right. So, data migration tools. Here's what you need to know. Amazon has data migration tools. No, I'm just kidding. So there's 3 online ones that actually require you to, be connected to the internet, and there's one offline one, which is the Snowball one. Now, if you want to move data into AWS, or you need edge devices with like large amounts of computing power that you want to run in like a factory or in a building or out in Antarctica or something like that, just know that the Snow Cone, the Snowball Edge, and the Snowmobile are basically your options. Particularly the Snowball and the Snowmobile have storage, like large amounts of storage. The Snow Cone only has 8 terabytes of storage, and it's really like an edge IoT device. It's not really a large scale computing device per se. But the Snowball Edge has both a storage option and a compute optimized option with a ridiculous number of processors, right? So yeah, I know it sounds weird, but the Snow Cone is really tiny. Like, I don't know why they didn't call it Snow Cone Edge, because it's a really tiny like space. It's for a portable server. So the Snowball process is that you go to the management console or API and you ask for either a Snow Cone or a Snowball Edge. If you want a Snowmobile, by the way, you have to talk to AWS directly to order that and set up that whole thing. And then what happens is it comes, you use it, and once you've uploaded your data over the network to these devices, you send it back to Amazon and they put it in your S3 bucket. Amazon, by the way, is going to use like a secure NIST guideline erasure. I can't remember what the DoD standard is that they use for that, but like they basically do a secure erasure of the disk. But it shows up in your S3 bucket. So, by the way, the Snowball Edge is really used if you need 70, like 80 terabytes is actually the advertised space. If you need 80 terabytes of less, you can actually order multiple Snowballs if you want to, but 80 terabytes or less. So like, basically if you have multi-terabyte, that's you're going to use a Snowball. Snowmobile, if I remember correctly, will store like 100 petabytes of information. So they say it's an exabyte scale data migration service, but only if you get a bunch of them. So I don't know why they just call it a petabyte scale service, because it's just petabytes. It's 100 petabytes. And so so just know those limits, by the way. Those show up on the exam. The Snowball Edge can only transfer 73 terabytes usable, at 80 terabytes is its maximum advertising. Snowball is 100 petabytes per Snowmobile. It, by the way, hooks into your data center, so just remember that the Snowmobile will connect, I think, via fiber into your data center. You may say, Michael, why would I do this? If your network connection isn't fast enough to transfer that data, a Snowball Edge is only going to take you 3 to 5 days to turn around. You get it, you upload your data, let's say it takes 2 days, you send it back, it takes 2 days for them to restore it, you're done. In a week, you've got your data copied up to Amazon. Sometimes your network speed is not fast enough for that. So that's why you use a Snowball for that. Snowmobile is if you're like doing a massive data center migration and you're uploading like, petabytes of information and you don't have time to go across the network, but you've got like a month or something to get it done. That's when you order a Snowmobile, right? I gotta tell you, I've never used a Snowmobile. Yeah, maybe one day, maybe never. So past the snowballs, if you're online, you can actually use this thing called data sync, where it actually puts an agent on your like shared file systems that you're sharing out to the world, like in your, not to the world, like into your like data center. Let's say you're sharing out like an NFS file system, right? If you run the data sync agent on like a virtual machine that has access to the shared file system, it will copy it up to the data sync service, and then it will stick it on S3 or EFS. Data sync is actually kind of fun. It's a really interesting thing that they created, and it transfers, over, whatever like network connection you have, right? And it'll limit itself. You can set rate limits in there if you want to. You can transfer like portions of the file server if you want to. But it writes into a region and then eventually converts it over to S3 and EFS. Now, this will transfer data, but will not present more storage into your data center. If you want to present more storage into your data center because you are running out of storage in your local data center, you can actually copy this virtual machine called the storage gateway, and it has 3 flavors. Excuse me. There is a file flavor, a tape flavor, and a disk volume flavor of this storage gateway solution. And what it does is it allows you to like take this virtual like machine, and it acts as a file gateway back to Amazon. So it looks like this. So here's storage gateway acting as a file gateway, and it's actually like presenting files out to, applications and or users, and it can either store data locally in your data center and cache it on S3, or it can store it on S3 and cache it on your local data center. So it's got different modes for how it runs. This is a virtual machine. It does run on VMware. I think it runs on Hyper-V as well, but VMware I know for certain. Hyper-V is speculation. But this is the file gateway mode. It also, by the way, other than the file gateway mode, has an iSCSI for volumes mode, and it has an iSCSI for tapes mode. So like if you want it to act as a tape gateway, like shows up as a tape device, you can take this little funky little virtual machine and make it look like a tape device. So your backup software can write backups to this tape device, and it's actually writing back to S3 and Glacier. So it's actually really cool. And so there's the 3 flavors where it's in file mode, volume mode, or in tape mode. And when it's in volume mode, by the way, it presents disks. They look like disks. Now, you do have to have some storage for that to work, but if you're running out of storage and you need to extend your storage, the storage gateway is a great option for extending storage. All right, here's a knowledge check. Which of the following is a petabyte scale data transfer solution? So remember what I said, but then also remember what I said Amazon thinks about these things, right? So for example, it says that the snowmobile is an exabyte scale solution, even though it only transfers 100 petabytes at a time. So which of these 2 did I say was the primary data transfer option? So Amazon is not going to call the snowmobile a petabyte scale option. It calls it an exabyte scale option, right? So I said that you would use A, but what is AWS going to tell you it is, right? And so Kyle, I think you hit it on the head. It's actually going to tell you that the Snowball Edge is what you're going to use, because the Snow Cone isn't really a data transfer device. The Snow Cone only has 8 terabytes of usable storage. The Snowball Edge has 80 terabytes of usable storage. So AWS is going to tell you that the Snowball Edge is a petabyte scale data transfer solution. Just make sure that distinction's in your brain. The Snow Cone is an edge computing device that has very little storage. The Snowball Edge is a storage transfer device. It can do 80 terabytes. The Snowball Mobile, according to Amazon, is an exabyte scale device that does 100 petabytes per. I know it's marketing, but you just gotta know it, especially if you're gonna take the exam. Which Amazon S3 feature can force an action to occur after an event takes place within a bucket? What if you needed to let Lambda know that it needed to respond to something that you did, right? What would you use to trigger Lambda? Good. Yeah, so you use event notification that, hey, Lambda, wake up. I just got a video file. Do something with it, right? Here's the video file. So that'd be event notification. I don't even know what invoking is. I don't think that's a product, by the way. And alarms belong to CloudWatch, Lambda belongs to Lambda, etc. Okay, you've got two Linux applications in two different availability zones that have to share a common file system. If you need to run across multiple availability zones and they're running Linux, which of these is perfect for running across availability zones for Linux boxes? That's right. Remember, FSX is typically for Windows. FSX for Lustre is a high performance computing device. Storage gateway is the one that we just talked about to extend storage. It's really EFS is the king here. This is the one you want to use. Okay, which of the following protocols are options in AWS Storage Gateway Appliance? So in other words, what are the three modes, of which there's only two flavors, right? So like to clarify that, one of the file modes actually has two different flavors to it, right? So I'll give you one of them. iSCSI is the one that does tape drives, and then it's the one that does volumes. But when you're doing a file server mode, it comes in two flavors. I've mentioned these two flavors several times, but I didn't call them out here specifically. A, B, and D. A, B, and D. Yep, that's right. So iSCSI is the low-level disk protocol. SMB and NFS are like a layer 7 like file system sharing protocol. So perfect. Okay, that's the end of module 5. Any questions about storage? Okay. All right, so we're moving on actually to database services, and notice that we're going to have a lab attached to this one. So we're gonna get to that as soon as we get back. It is 12 now, so we're actually going to stop at 12:30. So we're going to probably be in the middle of database. The database is actually a lot easier than, it's usually one of the smaller modules, so it's usually a lot easier to discuss than we usually think. Good. So I'll start the labs here in a second. Okay, so check in. Which of these are your responsibility if you run a database on an EC2 virtual machine? What are you responsible for? By the way, think of server maintenance as like host hardware maintenance. Database backups, that's true. OS patches, that's true. Scaling, that's also true. Yeah, so all that's true. Good, Kyle. All right, so we're going to talk about database applications, but remember, Amazon wants you to give as much operational responsibility to them as possible. They want to take it off your hands. So just remember is that Amazon doesn't want you rolling your databases on EC2. They don't really care. That's the most expensive way to do it, by the way. It is more expensive than using RDS, depending on what you're doing with RDS. But more operational overhead is on you if you do that. Now, you got more control. Maybe that's what you need. But it is more operationally burdensome to you. Now, this is where the database services come in. And I'm just going to forewarn you. There are so many database options available on AWS, and I'm only going to talk about a fraction of them. but they've got MongoDB, Cassandra, Kafka, which is not really a data store, more streaming data bus, but it's there. ActiveMQ, which is also a streaming bus, so again, not a data store per se. Elasticsearch, Solar, did I say Cassandra already? Neo4j, which is a graph database. They've got a bunch of flavors of relational database systems. So MariaDB, MySQL, Postgres, they've got all that stuff. Trying to think of like other things. They have a block ledger database. They have DynamoDB. They got a bunch of pretty much all the major flavors of stuff they have. So let's talk about relational and non-relational databases. What if we need a data warehouse solution like Redshift, which is what they have? What if you need a cache, which is they have Redis and Memcached, so they have caching options. And then are there any options if you want to migrate your database to the cloud? What are the pieces for that? Now, this is where we get into caching databases, and we get into what is called a relational database management system. So notice we've added that, and there's DynamoDB in the upper left-hand side. So we've got DynamoDB in that upper left-hand side as well. So don't forget that. I know it's real easy to pretend it's not there, but it is. Sorry, I'm moving something out of the way here. Okay. So let's talk about just database services at a high level. First of all, there's a bunch of them. And I forgot about TimeStream, which is a time series database. Cassandra, MongoDB compatibility, Neptune, which is Neo4j, DynamoDB, which is proprietary. There's a bunch out here. We're not going to talk about all of these. We're only going to talk about these. So RDBMSs, Aurora, which is Amazon's cloud version of the traditional RDBMSs, Redshift, which is a data warehouse, Elasticache, which is a caching database, and then DynamoDB, which is a NoSQL database that can handle like 10 trillion requests a day. Ridiculous. 20 million requests a second out of the box. So you got to understand a little bit about relational SQL-based systems, which are highly acidic and very transactions-based, versus non-relational systems, which are very dynamic in their data storage, but they do not enforce like consistency and integrity as strongly. They can, but out of the box, they don't. So this is relational data, meaning there's tables and the data has linkages together and it's very structured and there's rows and columns and everything needs to be in those columns, even if it's a null value. Like it's highly structured. Strong relationship between the data. NoSQL data, also known as key value data or document data or collection data or columnar KV data, bunch of names for it. This is partitioned into very simple keys. You ask for a key, you get the data. Do you need all the data? Well, you can filter it, right? But these systems scale very well for performance. These systems are more focused on data consistency and data accuracy. Now, you might say, Michael, why would I ever use this system if it's not accurate and it's not consistent? It is accurate and consistent. It's just not as accurate and consistent. In other words, you might not use this for financial data, but you might use this for social platforms like non-competitive scoring, tracking stats, searching for music or books or whatever, right? How often are you going to update that material anyway? Once you add a book, how often does the information about the book change? So what you're really looking for is, one, do I need to use SQL? Because if you do you have complex joins? What is this going to be a write-heavy database? It's not going to be good for an RDBMS as far as price per dollar. And how consistent or acidic does the data need to be? So this is where we come into this thing of like, do I use a traditional database or do I use one of them newfangled NoSQL databases, right? So just know, like, this is going to be a consistent conversation throughout the remainder of the service exploration. Now, RDS answers the question of, I need an SQL database. MariaDB, Postgres, MySQL, right? Whatever. So RDS allows you to deploy and maintain hardware, encryption at rest, multi-AZ data replication. So RDS is the relational database service. I don't know why they don't spell that out, but it's the relational database service. This is a platform as a service, meaning you do not log into the servers that are underneath these systems. Here are all the flavors. And I don't know why they list Aurora there, because Aurora is just a flavor of Postgres or MySQL. So very confusing. Aurora is a subproduct, and it offers a Postgres and MySQL flavor. It is not its own independent flavor, right? So these are the engines that you can launch inside RDS. They do use EC2 virtual machine t-shirt sizes. So when you launch these database engines, they run on a virtual machine that you cannot log into, but you specify when you start it. When we do the lab, by the way, you're going to launch RDS databases that are of a certain size. They're going to match the virtual machines. If we go back, by the way, to ec2instances.info, I just want to point out to you, see how there's an RDS tab here? If I'm looking for a certain size of RDS database, here it is. If I'm like, man, I really want a high memory type, here it is. High memory type. So just know you have options for this. But I didn't show you that before because we hadn't covered RDS, but there is an RDS tab for the different t-shirt sizes of virtual machines that you can get underneath your RDS instances. Reminder that you cannot log into these instances, right? They are capacity reservations, but Amazon's going to patch them, secure them, and do all the stuff. The only thing you can do is get into the database engine. That's it. Okay. So let's say that we're running a web server and it's talking to a single RDS instance and we're snapshotting the RDS instance out to S3. Here you've got multiple EC2 instances, and what happens is that if you hit this checkbox called multi-AZ, Amazon is going to launch a second server in another availability zone that you've specified, and they're going to replicate data in one direction, but it's going to be synchronous. And so if the primary system fails, Amazon will automatically, without doing anything with you, change the DNS name to the other database. So this is a multi-AZ deployment. This is not for read-only scenarios, right? This is what you use whenever you need to make sure that your database is fault tolerant to an availability zone failure. So this will automatically fail over for you. It can take anywhere from like half a second to 30 seconds from what I've seen. But these two databases will stay in sync with each other. Only one of them is accessible at a time. This does not enhance performance. This does not enhance performance. This does not enhance performance. It only enhances high availability. So here's a link of where instead of doing a multi-AZ deployment where you've got like two potential masters or leaders, if you will, of the database, one is active, one is passive. Let's say your problem is that you don't need redundancy. Your problem is that your database is getting killed with reads. Cool thing, you can actually start another copy of your database that maintains, instead of a synchronous replication, it uses asynchronous replication, meaning there could be a little bit of lag between the replication. With synchronous, there is no lag between the replication. So this new system, which has its own EC2 instance underneath it, is now a read-only system. And so now you've got a reader URL for these read replicas, and you've got a writer URL, which can also be a reader URL, but a writer URL for your primary database. So remember, your application logic has to support that, by the way. If it's read-only, it should go to the read replica. If it's writes, it should go to the primary database. By the way, if you take the read replica and you cut its ties to the primary database in order to make it a primary database, that's a great way to make a copy of a database that's actually live out in AWS. By the way, you can put that read replica in other regions. So if you want to actually take your primary database and run a backup copy of it in Tokyo, you can do that. Now, latency is going to cause the replication lag to probably be a second or two, but that might be acceptable to the business. If your primary fails, you just promote the read replica to a primary. You're ready to go. Now, in addition to having multi-AZs where you can have active passive failover, in addition to having read replicas, which by the way, I think you can have up to like 16, 15 read replicas. It's kind of crazy. Yeah, I don't need something to say to that. You can also do encryption at rest for your data. You can actually support also transparent data encryption if you're using Oracle or MS SQL. So you can enable encryption at the field level if you want to. Now, RDS does have a flavor of itself called Aurora, and this is a MySQL or Postgres compatible database. This database is fully managed, and unlike like the traditional MySQL and Postgres, if you take the same data set and the same data and you run it in Aurora, set up the exact same way, versus like plain standard Postgres and MySQL, Aurora is going to be 3 to 5 times faster. Let me back up for a second. So Calvin, you asked a question. When the primary fails, the read-only promotes itself to primary automatically? No, it does not. If you are using multi-AZ, the secondary automatically promotes itself. If you're using read replicas, which is a completely different thing than a multi-AZ deployment, it will not promote itself automatically. So you have to do that manually. If you're doing the multi-AZ failover, it automatically does it for you. You don't even have to touch your application. But read replicas are a different thing. So Aurora, which is the MySQL Postgres version, like that's cloud, like written for cloud, it's 3 to 5 times faster. The way they get away with that, by the way, is that they're actually writing directly to storage. So Amazon did this really cool thing where you're actually writing directly to disks instead of having to replicate it through a bunch of replicas, and reads are going to go across all the replicas. So they are doing this cool thing where it's almost like a multi kind of leader situation where you can have multiple replicas in play that are actually acting in conjunction with the primary. So you get a lot of engines in the race, if that makes any sense. Now, the other cool thing is that this is t-shirt size, just like the EC2 instances over on the RDS, like normal RDS. But Aurora also has a serverless version, which is sick. The first version of this was not awesome. The second version of this is actually pretty cool. You get a pool of pre-warmed instances that kind of like just hang in the background. And when you hit that database, like you run a query to get it, it hots it, like makes it hot, answers the request, and then goes back to a warm mode. You only like pay for this when you run a query. I mean, you pay like a little fee, like 5 cents an hour or something like that. But it shuts down when it's not in use, and you don't pay any fees. So you can actually like define your level of warmness if you want to. But this is scalable database capacity where you're not paying for a 24/7 virtual machine. This is pretty cool. So just know that they do have a serverless version for the Aurora Postgres and Aurora MySQL. Okay. And I got to tell you, this is a game changer. If we can get to this kind of level of serverless and its performance, your database costs will go way down, right? Way down. So the only thing you're paying for at that point is what you're storing and when it runs. Any questions about RDS or Aurora in any way, shape, or form? Okay. Let's talk then about DynamoDB which is Amazon's flagship database. Let's talk about this thing. Now, this is a flagship NoSQL database. So everything we just talked about was SQL based. This is an RDBMS. That's what RDS was. This is their premier NoSQL system, right? This is a fully managed database. There are no EC2 instances underneath here that you can ever see. This is completely serverless from your perspective. The way it works is that it works based on tables. You create a table. That table has read and write capacity units. How fast per second do you want to write? How fast per second do you want to read? You can, by the way, set that to auto scaling so it just responds to your requests, right? So it scales automatically. You never see any servers here. This is a truly serverless, highly managed platform. You just dump your data in here, as an example, with a key, and you just retrieve it. Leaderboards, social data, cart data, session data, perfect. Search, just like any kind of data dump is really good for DynamoDB. Even some transactional data will work here, just depends on the type of transactional data. Now, in this particular case, you got a web store with a shopping cart, and that shopping cart is a DynamoDB database. Very flexible schema for this, by the way, right? Here, they're using it to search, right? For obviously like a movie or actors inside of a movie, right? Notice that you have to create searchable keys on your data. Is it going to be artist and then song title? Is it going to be here, actor and role? Like, you can create these keys and you can search on the keys and then get all the data associated with that key. And you can filter that either server side or client side. So if you don't want all the data, you can dump it. But note that it's, you can key this up however you see fit. So you have to have a partition key, which is at least one key. If you want to add a second key so you can actually search better, the sort key actually allows you to query more precisely. Everything else is just an attribute. And by the way, notice that some of these fields are empty. You can't do that with an SQL database. With an SQL database, you at least have to have a null there, right? Now note that this is a fully serverless system and it's fully auto-scale managed if you want it to be. So you don't have to worry about bad performance unless you just decide to set horrible limits for yourself. So here, you can actually set it in two modes, either provision mode or on demand. Provision mode says this is the minimum I want to pay for. This is the maximum I want to pay for. Scale in between there. And on demand says, well, you can go all the way to 0, and then I want you to go all the way up. Now, for spiky or unpredictable workloads, they recommend that you use on demand. If you know what your workload is going to be against a database, they recommend that you use provisioned because you can just keep it within a steady state. Because if all of a sudden someone decides to hit your on-demand database for 10,000 hits a second, that could get expensive. If you want to set limits, use provisioned, right? I do want to mention that provisioned can take minutes to scale. On demand will take seconds to scale. So there is a performance difference between these two. On demand will take seconds to scale, right? Auto scaling is going to take minutes. So you can also, by the way, make this database strongly consistent if you don't mind a little bit of a performance hit. And I say a performance hit, it might be more of a cost hit, actually. It's not really a performance hit. But eventually consistent, you can get, if you can be loose with it, with your consistency, your data consistency, then eventually consistent will work. If it's a leaderboard or like data that isn't really it's not like financial data or extremely important that it reflect the actual real-time state of the number, eventually consistent will probably work. You can also set up globally replicated tables, which allow you to replicate, the world over. So you can actually just, replicate data across the entire world. This is eventually consistent. So this is a multi-region, multi-active database that you can run across the world, and you don't have to set up your own replication. It's pretty good, actually. Just note It is eventually consistent, so this isn't strongly consistent. This will eventually get all the numbers replicated, but it can take seconds for that to happen. And that's the little tracky story about DynamoDB. Any questions about that database, that flagship database? All right. Maybe one more like little quick run here, because this one's a pretty simple one. This is Redshift. Redshift is the data warehousing tool. So DynamoDB is a NoSQL database. RDS is an SQL database system. This one is also an SQL database system, but it's used for data warehousing. This is where you dump data. Well, instead of doing transactions, you're going to do analysis. It's OLAP, really, right? Structured data only. And what this is for is really for aggregates of data. Now, the way this works is that you can use JDBC or ODBC to connect to a leader node, which will then parallelize queries out to all of the compute nodes. So this is OLAP at its finest. This is massive parallelization. This is parallel processing capability. This can read from S3 and it can dump to S3. And it's really in like a distributed query processing. There's a lot of strong transactional consistency here. This is a fully managed system, but it does use nodes, but you can't log into them, right? So this was launched in 2012. It's been around for a while. You can use this for business intelligence, predictive analytics, data as a service, operational analytics. It's really powerful. This is what it does. So it does, this is columnar storage. This is what it's optimized for. It is optimized for searching along columns, not searching along rows, right? So it can find aggregates over large data sets really quickly. So loading less data into memory, by the way, because if they store it in a columnar format, it's really quick to find on disk. But this allows Redshift to perform faster, more like efficient in-memory queries because everything's aggregated, right? So it can filter out large data sets quickly. You can actually have multiple clusters. So you can have scalable concurrent users and queries that actually scale along clusters. So like Redshift will add additional compute node clusters as needed to support your concurrency scaling if you have that set up. So if you have a cluster that has concurrency scaling turned on, if the leader node receives a request that's like too large or like fits the requirement, it'll actually add a concurrency cluster and then send that query out. This is not for real-time returns, by the way. If you want that, use RDS. This is for large reports that take a while to run because you're running aggregation reports. You're running analysis, right? So it's going to kick these out to a query, run it for 8 hours, and then give it back to you, or 4 hours or 2 or whatever it is, right? So the extra processing power is removed once that report or query is run. Now, it does use cluster nodes to create these funky little clusters. And there are there's like RA3 nodes, there's DCT nodes, they have local SSD storage. That's a whole level of specialization, right? So the RA3 or these 16x larges, they have scalable storage. You've got the DC2s, and I think you've got DC3s now as well. I think that's right. Maybe the RA3s and the DC2s are getting crossed in my head. But the DC3s are really dense nodes. Sorry, the DC2s are really dense nodes. So we recommend that, Amazon recommends that you use the RA3s because they're the best like mix of compute and storage. The DC2 is kind of the old way of doing Redshift where it's really focused on compute really heavily, okay? So the main thing for you to remember, Redshift is the data warehousing service. It is columnar-based storage. It is perfect for OLAP, which is analytics instead of transactions. It does scale clusters. It works off the concepts of nodes, and some of the nodes are more flexible than others. The RA3 is the current node they recommend that you use. That's it. Okay. Questions before we break for lunch about Redshift DynamoDB or RDS? Okay, so it's 12:29 by my watch. We're actually going to come back at 1:02 because I'm walking in the door right at 1 o'clock. So we're going to come back at 1:02. So at 1:02, we're going to resume. Sorry, did I say 1:02? What am I saying? Sorry, 1:32. So at 1:32, we're actually coming right back in here. So at 1:32. So I'm going to put a timer up. Otherwise, go to lunch, try to get away from your computer, let all of this information sink in. We're probably going to talk for like 20 more minutes, maybe, and then we're going to roll into a lab so you can stop hearing me talk. Then we're going to do monitoring and some other things this afternoon, okay? So go have an enjoyable lunch, and we'll talk to you in a bit. All right. Actually, let me make sure this is recording. We take a look at this ramp up guide out here. Did I download it? Maybe I didn't. Let's grab it. If we take a look at this thing, just to mention this, is that this is a step-by-step like training tool that actually prepares you for the role, not the certification. Be clear about this. It makes sure that you have all of the well-rounded understanding and the skills to do the certification. This is a great tool if you're preparing for a role. It's also great to prepare for the certification, but it's slightly inefficient in that it's got more in here than you actually need to pass the certification. Just to say this. Now, I'm a big fan of you having the skills and the certification. So it's not like we diminished it somehow, and so therefore you don't actually know what you're doing if you get the certification. That's not what's happening. But this is like really overkill because this trains you for everything that you would encounter as a solutions architect, not everything that you might encounter as a solutions architect, specifically on this different subjects of AWS, right? So here is this particular guide. So this is the ramp up guide. So in terms of what's in the training materials section, the attendees materials, right? What will happen is that this ramp up guide, for the most part, you can ignore, right? So with the certification study guide, this particular spreadsheet, this one is a little leaner. And what this does is this gives you the specific white papers and some labs that you could possibly do to round out. Now, I would actually recommend that.
Michael, we're not sure that you're putting the right page on the display.
What are you seeing right now?
EC2 instance info for RDS.
So you're not seeing this?
Now we do.
Oh, that's so weird. Because I didn't actually change sharing. I just reset it. Huh, thank you for saying something. So this is the page that I was at, right? This is the actual like attendee material section of GoToMeeting. And I'm going to email all this to you, right? But this is also here. It's also in the interface. So if you click on the material section, that's available inside the GoToMeeting interface, not the web one. Although it is somewhere on the web, I just don't know where it's at because I've never used the web interface. I only actually use the application. I'll have to look at, well, I was going to look at that for labs. But this is what's inside the material section for you all right now. The ramp up guide, which is the thing at the bottom that I was just talking about, this is the thing that I was just scrolling through here that basically gives you a step-by-step guide for how to prepare for the role, not just as an associate solutions architect, but also as a pro. So notice that the associates like digital training, exam readiness, and the exam certification guide are down here. But if you keep going, you get to pro. I gotta tell you, it seems like there's something missing from this guide because this is not all that you need to do in order to get ready for pro. There's some things missing here. So if you ever decide to take the pro class with us, I have a much better section here, but this is deficient to pass for the professional exam. It's a little strange. There's only 5 items here that last like 3 hours. There's a huge difference between the associate's exam and the pro exam between those 2 exams. So I don't know what this little, so it seems like they snipped a page or 2 accidentally. So this one, for the most part, you can ignore, but if you need to deep dive into a topic, it's here, right? So if you need to like do a lab on a key management service, you can just click over here to self-paced labs and get access. So just know, right? there are options, right, to get deeper if you want to train for your role. Now, the certification guide that we gave you, this one is a simplified guide that is a little bit more narrowed down to the things you're actually going to need to do and know to pass the exam. It's not that it's like makes you a deficient solutions architect, but as several of the architects have commented, this is a little bit of overtraining. It's super complete, but it's exhaustive. This one is super focused. So we recommend that you use this one actually. This one, by the way, has you studying for 1, 2, 3, 4, 5, 6, 7, 8 weeks at 5 hours or less a week. So you can go faster on this if you want to. Notice that you'll see that it always starts with a 3-day class, which is what you're taking right now. And then there's about, almost 5 hours of study around the well-architected framework, security best practices, and how pricing works in AWS. Then there's a just shy, right, of 5 hours study of the well-architected framework, some labs, and backup and recovery approaches. Notice there's a little over 5 hours here of study around secure multi-VPC, connectivity, and architecting serverless solutions. And then the rest of this time is about 3 hours a week of practice exam study, of which we are providing the practice exams to you for free as part of you taking this class, right? And so you get access to Tutorials Dojo, which is what we're going to do tomorrow, where we're actually going to look at the practice exams, and I'm going to teach you the strategies and thoughts around how to decompose these questions, right, that you're going to see on the exam. Not hard, but it's things like excluding the wrong answers, understanding what keywords like scalability and high availability they're keying on. So between this study guide and the papers that are here and the practice exams, you should get all of the practice you need to at least get the expertise to pass the exam. Now, the Solutions Architect Associates exam is not a hands-on exam. So this is not the SysOps Administrator exam, which is hands-on or has a hands-on component. But you still need to know like how to do your job. And so the other piece that we have here is that inside this training material, you've got this study guide that I was just looking at. And then here is accessing the practice exams. And by the way, you probably want to follow this as soon as possible. And please use the email address that you registered for the class with, because that's what we have inside of the Tutorials Dojo system. Let me touch on that for just a second before I talk about the labs. This document right here shows you step by step about how you sign up, right? You must use the email address that you used that I showed you yesterday, that you use to log in, for example, to Quick Labs. You have to use that email address. If you don't, then you're going to have to contact us. We're going to have to change things. It's going to be a 24-hour delay. But just know you have to register an account on the checkout page before you can access the content. So that means you have to go to basically this link, which is portals.tutorialdojo.com, and then apply the coupon code, which is provided to you by Web-based Solutions on the checkout page. So you're going to register an account, buy the exam, you're going to use the coupon code. Coupon code is going to allow you to get access to this practice exam. The practice exams are all located at this website, which some of you saw yesterday afternoon when we were looking at it, which is Tutorials Dojo. Tutorials Dojo has practice exams for all of the AWS exams. Oh, please stop. Here, by the way, you have the Solutions Architect Associates exams, which is what we're looking at. Here, by the way, are going to be, for example, things like, hold on, let me sign in really quick. Seriously? Oh, I'm going to write a letter about that. You just changed context on me once I logged in. Not a good user experience. Anyway, so in here, the only thing you're actually going to run is you're going to run the review mode exams. So the review mode exams right here under review mode, not the time mode, not the section base, not the topic base, not the final test. You're going to spend all your time mastering at least 2, sometimes 3 of these sets of questions. And you're going to do it until you get 90%. We have passed hundreds, if not thousands of people using this method, And it works remarkably well if you follow that setup. So, in the study guide, what ends up happening is that you read all these white papers. Hold on, let me blow this up a little bit. You read all these white papers, you take these digital trainings, and then you're just doing exam practice for the last 3 weeks of your study. This is where you're actually doing the exam practice. This inside the review mode sets is where you are actually studying each question in detail, learning why that answer is right and learning why the other answers are wrong, because they tell you when they take the exam. Okay? So you're going to take this guide and you're going to do the first few weeks of it after you take this class. You're going to read the white papers. You're not going to memorize them. You're going to skim them and note the key points. Then you're going to end by taking these web-based exams, the ones that are here at Tutorials Dojo. You're going to take one set of these questions and take it again and again until you can get a 90%. Then you're going to do the second set of questions. You're going to take that one again and again and again until you get 90%. And if you're really new to AWS, you're going to take a third set and you're going to take that until you get 90%. Once you can consistently get 90% across 2 sets of these review mode questions, you're ready to take the exam. I'm not guaranteeing you're going to pass. I'm just saying that you've done a lot of training, and at that point in time, you've learned a lot of trivia, services, integrations, all this other stuff. You're ready to take the exam at that point in time if you can get 90% across 2 of these exam sets. And that's really what this study guide is actually telling you, is that once you get that marker in week 3, let's go ahead and sign up for the exam at that point in time. Okay? So these documents are all inside this materials section, which is, again, either on the GoToMeeting interface or I'm going to find out where it is on the web interface. Regardless, Greg Wagner from WebAge Solutions already told me that he was going to email you this entire zip package before the end of the day tomorrow to make sure that you had everything. The other thing that might be of use to you is that you might be a hands-on person. So this is getting access to the supplemental labs inside of a place called Quick Labs. Now, Quick Labs you've already seen because we've used it, right? Hold on one second. Here we go. We've used this already in order to get access to our labs. Oops, hold on. Inside of AWS. Here we go. So note that this is not webage.quicklabs.com we're talking about. This is amazon.quicklabs.com. This is the public site for Quick Labs. Anybody in the world can come and sign up for this, but you get some of these supplemental labs for free. So what's going to happen is that you're going to go to www, which is the same as Amazon. It's the same thing, right? The difference is that amazon.quicklabs.com is scoped only to Amazon. You're going to click the join link in the page. You're going to create an account. You have to use the same email address that you use to sign up for training. So the same email address that you used for webage.quicklabs.com, you're going to use at amazon.quicklabs.com or www. It's the same site, right? And you're going to log in. And what will happen is that you're going to have some credits assigned to your email address. How do you know? If you click on this picture in the upper right-hand side, you can see that I have 8 credits under my name. You're going to have like somewhere between 20 and 40 credits probably assigned to your name. And the reason this is significant is that we have a list of labs that you're going to take, and they're all under this catalog. Most of them are introduction labs. And so what you can do is that some of them are free. They're not going to cost you any credits. If you've never touched API Gateway, guess what? Now that you've created an account, you can go in and take this one for free. There are 13 free labs at my last count. But here's one for load balancing that's going to cost you a credit. Here's one for DynamoDB, that's free. Here's another one for KMS, that's free. Here's another one that's 1 credit. My point being is that we're going to give you a number of credits and we're going to give you a list of labs. But if you're like, Michael, I'm really not getting the concept of DynamoDB or Lambda. come in here and run a lab on Lambda. Run a lab on DynamoDB. I guarantee you if you do that, it will drive the concept home and you'll have a better understanding of it. So just know that if you're someone who like, I can read white papers, but it's boring and I don't really get it and never really drives it home, if you need to come in here and read those papers and do labs, we're going to, like, this is the way you get it done. And like I said, we're going to give you a little bundle of credit so you can actually take labs based on a list that we give you. So you're going to get a list of labs that we know are appropriate for the Solutions Architect Associate exam, okay? And so that's going to be added to this page, this training materials page. So thus far, just to rescope that, you've got the ramp up guide just in case you ever need it. It's going to give you more resources than you actually need to prepare for your role and your certification with solutions architecture. But we also have the simple certification study guide. We also have the accessing supplemental quick labs, and then we have the accessing practice exams. Those two top instructions you should just do one time and then just let them go. But that certification study guide, you keep it, and that will allow you to like follow step by step the program that we've put out so you can pass the certification and be prepared to actually do the work the certification represents. Only thing that I don't see here is that list of supplemental labs that are associated with the Solutions Architect Associate. We'll make sure that's up there tomorrow, right? So it'll probably be tomorrow before you see it. And then of course we'll put up a little list of links as well because I promised to do that earlier, like ec2instances.info, ec2 spot workshops, all the workshops that I know about that you could do, right? That's probably for future reference, but just so you can have the resources, okay? Questions thus far? Okay. Tutorials Dojo, yep, all right, good. All right. Let's do this really quick since we're here. Let's take a look at some of the questions since we got a few more minutes because I promised I would spend 30 minutes on this, right? Let's talk about some of the questions you're going to see. Hold on 1 second. All right, let's say that we're going to look at review mode set 4, right? Now, I'm sure I've probably already looked at this, but let's look at it again. Now, notice, by the way, when we sign you up, you get access to these for 3 years. So this is when I bought these, is actually in March. But you get access for 3 years. So let's take a look at this question, all right? I'm going to deconstruct this for you first, and then we're going to open it up so you can answer it. So you got a large multinational investment bank. It's got a web app that requires a minimum of 4 EC2 instances to ensure it can cater to its users across the globe. You are instructed to ensure fault tolerance of this system. What's missing here is to Amazon best practices, because you're taking an Amazon test, right? So to Amazon's best practices. Which of the following is the best option? Which of these makes sense here, by the way? Do we want to run 2 instances across 2 AZs, 2 instances in each of 3 AZs, 4 instances in 1 AZ, right? Or 1 instance in 4 AZs? Which of these is the best answer? Because everything else is the same. What does Amazon ask you to do as far as how you create fault tolerance across a set of EC2 instances? Usually A, B, C, or D, by the way, for those who want to type it in. Okay, so good. So I'm glad you answered. So notice what I did there, by the way, is that once I realized the first part of this question was all the same, I just pretty much ignored it. You know why? Because there was no differentiators there. And then I focused on this because this is the piece that is the difference between all of these, right? Now, Amazon says that at a minimum, ideally, you use 2 availability zones to run your applications. The problem with 3 availability zones or 4 availability zones is that unnecessarily increases complexity, because Amazon doesn't typically, they either fail across the entire world or they fail in 1 availability zone. They don't typically just lose 2 availability zones, right? And so the problem is that their recommendation is that at a minimum you run across 2 availability zones. But the rest of this is overkill, and this is not awesome because you're actually increasing complexity by running it across 4 AZs. What you actually really need at a minimum, what their recommendation is, and the one that has the least amount of operational overhead and complexity, is this one: 2 instances and 2 AZs first. But maybe I'm just making that up. Let's see what they actually say, because maybe I'm just over here smoking something, right? Aha! So Amazon in this particular case, right, wanted you to do 2 instances in each of 3 availability zones behind a load balancer. So let's see why that is, right? Because I got that wrong. So let's find out what the correction is inside of my thinking, right? So fault tolerance is the ability to remain operational even if some of the components would fail. But see, here's where, and I did this on purpose, right? Not the availability zone stuff, but I left out a key requirement that was in the question, right? Is that you have to have a minimum of 4 instances running in order for it to function. And so the funky thing is that, well, then I actually need to make sure that 4 instances are running at any given time. If I do 2 instances in 2 availability zones, Amazon's going to be like, you're going to lose an availability zone, you're going to go down to 2 instances. That's not going to work. So what they're saying here is that if we do this one and I lose an AZ, I'm down to 4. If I do this one and I lose an AZ, I'm down to 0. If I do this one and I lose an AZ, I'm down to 3, right? So so one thing to key in on is that, do you actually have all the requirements of the question front and center before you start evaluating these questions, right? So make sure that if it says things like this needs to happen and this needs to happen, make sure you put both of those into your brain as you're evaluating the answers, right? Because otherwise the 2 to 2 thing isn't going to work. You need the 2 to 3 thing in order to maintain 4 instances. So that still meets a minimum of running across a minimum of 2 AZs, but now we've added a third because we have to have 4 instances, right? Cool. By the way, all of this that I, just pulled out is all explained down here, right? It says, by the way, hey, there's only going to be 2 instances running. That's not going to work. No running instances. There's only going to be 3 instances. Same thing. Now, cool thing about John's stuff, he's going to tell you exactly from the Amazon documentation where he got this. Then he's going to have a cheat sheet just in case, you need to see a bunch of cheat sheets. And then he has his own study guide, which I don't recommend you use, right? So this doesn't show up all the time, but this typically shows up, including sometimes a video, right? Okay, let's do another one. So this time we're gonna delineate all the requirements clearly, okay? You have 200 terabytes of backup files in S3. Statement of fact. The files are in a vendor proprietary format. That's interesting. The SA needs to use the proprietary file conversion software to retrieve the files from the bucket, transform the files to an industry standard format, and re-upload the files to S3. The solution must minimize data transfer costs. Oh. So if you want to not pay for S3 transfer costs, we literally talked about this morning, and notice it says, hey, by the way, deploy on EC2, deploy on EC2, export the data to Snowball Edge, install the file conversion software. So let's do some elimination first, okay? First of all, you can't install anything in S3. You can use Lambda in S3, but you can't install a software in S3. It doesn't host software. Snowball Edge device, no. First of all, if you pull all the data out, you're going to pay maximum data transfer charges, so that doesn't work. So now we've got these last two answers. And just to say this, when Amazon gives you two answers that look remarkably similar, most likely one of those two answers is going to be the right answer. That's the standard thing. Now, in this particular case, the main difference is, well, install, perform and re-upload. So the only distinction is, are we running it in the same region? Or are we running the EC2 instance in a different region? That's the only difference between these two answers. And what were our requirements? 1, we have to use the file conversion software. Check, we're using an EC2 instance. That's solved. 2, we have to minimize data transfer costs. So if you remember from the slide earlier, it said, just like Jorge posted, right? It said that basically, if you want to minimize data transfer costs and you don't want to pay anything, deploy your EC2 virtual machine in the same region as the S3 bucket. So it's going to be in the same region as the S3 bucket, and then at that point, you won't pay any data costs, right? And so what will happen is that that's the right answer. This level of rationalization and understanding the services and being able to deconstruction, this is why we have you take the practice exams, so that you know how to find the answer. By the way, this just gets worse as you go up the chain as far as like the tests go. So this is actually pretty straightforward. The scenario-based ones for the pro and the specialty exams, they're like a murder mystery. All right, we're going to do one more. By the way, here's all the answers, right? Okay, you got a compliance rule in your company that says that audits every Windows and Linux EC2 instance each month to find any performance issues. They have more than 100 EC2 virtual machines running in production. Each must have a logging function that collects various system details about that instance. The sysops team is going to review those logs and analyze their contents using AWS analytics tools, and the results are going to have to be retained in an S3 bucket. So, how are you going to view any performance issues, right? How are you going to get a logging function? How are you going to analyze their contents using tools? And how are you going to store everything in an S3 bucket? So there's 4 requirements. 1, we got to get logs. 2, we got to get performance issues captured, right? So we got to get insights into the performance of the systems, right? And then we've got to analyze the contents using AWS tools, and we're going to put them in S3, okay? So then we got some things set up, right? Inspector agent, CloudWatch dashboard. We got the SSM agent, push data to CloudWatch logs, analyze with logs insights, install an SDK in each instance. I can't even read that one. That's not even close to our answer. Install the CloudWatch agents, push data to CloudWatch logs, analyze the log data with CloudWatch logs insights. Okay. So we've got 2 very similar answers, just to say this. So first of all, installing an SDK is a no, because why? The inspector agent is actually used for security vulnerabilities, not for logging. So that's not going to work, right? So it looks like these 2 answers are the right ones, right? Now, what's interesting is that the systems manager agent will collect and push data to CloudWatch logs, or will the CloudWatch logs agent push data to CloudWatch logs? Both of these are using CloudWatch logs insights, so there's no distinctions there. So tell me, if you're going to collect logs, are you going to use the systems manager agent, or are you going to use the CloudWatch logs agent? Let me see some guesses here. Or if you know, don't take a guess, put it out there. So SSM agent, I got 1 vote for the SSM agent. Now, what's interesting is that I know the SSM has an agent. Does CloudWatch logs have an agent? Speculating. Because I would think it would be the CloudWatch logs agent. Does it? But doesn't the system agent also collect logs? All right, so the only vote I got from Maria, she was bold enough to put a B. Let's see what the answer is, right? So in this particular case, the answer is actually that there is a CloudWatch logs agent, actually. There's a CloudWatch agent, there's a CloudWatch logs agent, there's an SSM agent, there's a inspector agent, there's like a couple, there's a X-ray daemon agent that you can run, there's a service lens agent, there's all kinds of agents, right? So in this particular case, if we go and look, we know that the SDK is not a valid solution. Although you could use SSM, it's more efficient than to actually use the CloudWatch agent, right? Manually collecting to an instance to view log files is time consuming. So you can actually get logs with an SSM agent. The problem is that it's more of a manual process. With the CloudWatch agent itself, you can actually just send the log data directly to CloudWatch logs. You can't do that with SSM. With SSM, you have to like look at the system, right? And inspector is not the right answer because, frankly, it's a security tool. It's not a logging tool. Yeah. So here, by the way, is the SSM agent. Here's the using CloudWatch to analyze log data, and here's CloudWatch logs, right? If you want to see that. Oh, yeah. Hold on. Yep. All right. So that gives you a feel for the questions, right? So I just wanted you to see that because tomorrow, all we're going to do is spend time parsing through that. Sorry, Calvin, can you clarify your question? So Calvin, let's see. It says use SSM agent to collect and push to CloudWatch. No, you're going to use the CloudWatch logs agent, right? So CloudWatch has a monitoring agent and it has a logging agent that you can use. And then SSM, the systems manager agent, is used for like automation. You can get access to like logs and stuff on the system, but it's a lot more of a manual process than it is if you use CloudWatch logs. Okay. So that gives you a feel for Tutorials Dojo, and so it should give you a good idea of kind of what we're setting you up for, right? All right. We'll come back to that tomorrow. Okay. So I'm going to play with this while you guys are doing a lab just to see if I can figure out how to make sure you have access to this. All right. All right, one more thing. Let's see. To make sure our labs are start up. So Kyle, where did you find it at? Was it on the web interface? I'm not sure if you're using the web interface. Some people are, and they seem to be having trouble getting access to it. All right. Let's cover this last little bit. And right now your labs are warming up. Oh, you got access to the Tutorials Dojo. Perfect. Okay, good. I'm glad that you got it. So if you got it, it probably means that everybody else is either about to get it or already has it. So that's perfect. Okay. Let's say that we're now continuing our database discussion and we realize that we really need to put some caching in front of our database because users are running the same queries again and again and again. And some of the results are expensive join operations, so that even with read replicas, we're actually seeing some latency, and so we need to improve the performance of the results of some of these complex queries. So when you don't have caches, what happens is that the EC2 instances are talking directly to the database, and it could be DynamoDB, it could be anything, honestly. This could be session data, right? That they're trying to pull from this system. And what happens is that if a lot of this is repeat computation, then you're unnecessarily having basically a compute engine recompute it every time. You're just having it like do the same work over and over again. What if instead, excuse me, instead of storing it in an index on a system like that, you could instead actually stick it on a cache whose job it is actually just maintain a copy of it. So in this case, you've got a side cache, which means it's not actually in line, right? In this particular case, Redis and Memcached are two open source tools that actually do caching. And so what happens here is that there's a couple of different caching strategies that you can apply to this kind of scenario, right? Where you've got a side cache and the application is going to read from the cache first before it actually goes to the database. If it doesn't find it in the cache, then it's going to talk to the database. This all happens in milliseconds, by the way. So notice here that in this lazy loading caching strategy, right, the data is actually looked for in the cache first. If it doesn't find it in the cache, it goes and gets it from the database, returns it to the application, to the user, and then the application actually goes ahead and writes a copy of it into the cache. Now, what happens here is that updates are being made to the database and they're not being updated in the cache. So the cache is not staying in lockstep with the database. Here's the cool thing about this. You don't have to have a big cache for it to be effective, but there is a penalty if you miss the cache, sometimes like milliseconds, right? So this is lazy loading, which means you only load it into cache if it actually is needed by the user or the application. Contrast this with write through, which says, hey, you know what we're going to do instead? Every time we make a write to the database, we're going to write over to the cache. So the problem with this is that you definitely have a fewer cache misses, meaning that data is in the cache. It also means that you're going to have a bunch of data in the cache that you actually don't need. Another way to do this, by the way, is to preload the cache, right? Like at the beginning of the day with like a bunch of unchanging data, and then just either use a combination of lazy loading or write through. So there's like a prefetch strategy that you can use as well to preload caches, like to warm them up, right? But write through and lazy loading are the two methods that people use to kind of load up their Elasticaches, okay? Now, Elasticache is the service that we use for this. It comes in two flavors, Memcached and Elasticache for Redis. So Redis is used when you want sorting, ranking, complex data structures. You want multiple AZ setups with failover. Redis by far seems to be more popular for any kind of complexity in caching. But if you need something that just scales off of a single node, then Memcache is probably going to be a better option. But note that Memcache does not have advanced data types, does not have sorting and ranking, no pub/sub capabilities. It does not have any of the capabilities that Redis has. So most people end up using Redis, right? So, Memcached can scale horizontally a little better, but that doesn't make up for the fact that people love all of Redis's capabilities. And by the way, there's a third option now. It's called Elasticache for managed Redis. And so for those who just love Redis, you can now get it as a standalone product that's not just designed for caching. So I think they just announced that recently. But these are the two open source products that make up Elasticache. So it's one of these two options. Remember I said that everything, almost all the database tools inside of AWS were actually based on open source products. Here you go. There it is. By the way, lazy loading does allow for stale data, but it doesn't work with empty nodes. Like if you've added a new node to the system, you're going to hit cache misses all the time, right? So one way to kind of get around this, if you need to like remove items from a cache because you've like preloaded it or you've written a bunch of stuff in there that isn't useful, is to add time to lives, kind of like you do with DNS records. So you can actually add time to lives to things, which will actually expire it out of cache and force it to go back to the database to get information. So just know that you can manage the freshness of your data through this methodology. Now, in addition to Elasticache, DynamoDB has an accelerator that acts as a cache in front of DynamoDB. You might say, Michael, if DynamoDB can handle 20 million transactions a second, why do you need a cache? Well, DynamoDB will get you down to single millisecond response times. If you need microsecond response times to your application, DAX is what you need. Now, I know that sounds crazy, but like if you're doing like a lot of like, you're running like a day trading application of some type, you might need that microsecond response time in order to like be competitive, right? So this is a caching service, and it's going to provide in-memory performance for DynamoDB. So this is called DAX, DAX, but the long name is the DynamoDB accelerator. Here it is without DAX, by the way, right? Milliseconds of response time could be causing lag. With DAX, you throw it in there, then you get microsecond response time. Okay. Okay. Moving past caching, does anyone have any questions before we dive into database migration tools? Three products: Elasticache for Redis, Elasticache for Memcached, and then DAX, the DynamoDB accelerator. Okay, I don't know why they don't spell this out. They call it DMS. It's the database migration service. So AWS DMS is the database migration service. And so DMS is going to support migration between like most of the widely used databases, right? It supports homogeneous and heterogeneous transfers. This can be used to migrate between databases that are on premise, so on somebody's data center, into RDS or to EC2. So, you cannot migrate, by the way, between two on-premise databases. So you can go in either direction, but you can't migrate between two on-premise databases. One of the sources has to be on AWS, right? It will not handle schema or code conversion, right? DNS will automatically handle formatting of the source data for consumption by the target database. But if you need to perform schema or code conversion between two like disparate systems, then you're going to have to use this tool as well. This tool will actually convert you from one database type to another database type. And so it can basically scan your entire like source code for SQL statements and convert them as part of a database schema. It can also scan your database. So it can convert legacy Oracle and SQL functions to their modern equivalents, so it can modernize at the same time that it helps you convert, right? It can also, by the way, help you migrate to Redshift, because you can see it in the list over there, DynamoDB, Aurora. You get the options. Yeah, nothing else to add there. So just remember is that the DMS is going to migrate data and do some like format conversions for data, but this SCT tool is what's required if you're going to go from one database type to another database type. Remember that with DMS, one of these databases must be on cloud. So you can't do on-prem to on-prem conversion. All right, here's a little knowledge check. What is the benefit of using RDS in a multi-AZ configuration? Ooh, I talked about this. What's it provide? Let's hear it. Provides automatic failover across availability zones. What? Are you sure? Yeah, that's the answer. Good job. Okay. What type of Elasticache installation offers sorting and ranking capabilities for data sets? Don't play around. You know the answer to this. I made a big deal out of it. It was the one that had all the checkboxes on the side, right? I mean, I'm not saying you should have a favorite kid, but one of these database technologies for caching was better than the other. Good. So Elasticache for Redis, right? Okay. Which of the following is true regarding the DynamoDB global tables? All right. So remember, the whole reason we use global tables is so we don't have to do manual updates, and all the tables are active at any given time. Remember, DynamoDB is completely serverless, so you don't use instance sizes, but the tables can be in different regions. That's the whole reason you use global tables, so you can have tables in different regions. So just remember that global tables are available globally, right, across the world, so in different regions. What type of storage does Redshift use? I made a big deal out of this. Good, I see you corrected it. So key value pairs are used for which man, I just said it out loud. For which DynamoDB database? It's used for DynamoDB. Row-based storage is used for RDS. Well, JSON is just like a payload type, right? So forget that. That's not even applicable. But columnar storage is how Redshift actually stores its data, right? Because remember, it's optimized for analytics, for aggregates, not for transactions, which is what row-based storage is for. So in this case, it's definitely columnar storage. Columnar storage. Okay, which of the following is true regarding an Aurora database? Good. Yeah, so the answer there is C, right? Aurora is compatible with MySQL and PostgreSQL, or sorry, Postgres. We don't usually pronounce the Postgres SQL. It's usually just Postgres. That's what we refer to it as. I don't know why I did that. Good. Okay. Now we're going to do lab 3. Da, da, da. Any questions about any database technology before we talk about this lab? This lab is typically estimated to be at about 30 minutes or less. So, we're going to run this until about 3 o'clock. Here's what you're going to do. It's already cooking in the background, so it's preparing all this for you. But you're going to have an internet gateway with an application load balancer talking to an app. And what's going to happen is that you're going to install a database for it, create the application load balancer, define the load balancer targets and rules. It's going to give you some exposure to a load balancer, which I don't even think we've talked about yet. And then you're going to test connectivity to an Amazon EC2 through the load balancer, and then you're going to test connectivity to the RDS DB instance using the console. So you're going to learn about how a load balancer load balances traffic, in this case to just a single instance, but you're going to see the targets and rules that you can use. You're going to connect to EC2 through the load balancer, and then you're going to check the database that you created. So that's it. Now, if we go over to the lab itself, which is over in Quick Labs. If you hit the start button, it should work because there are like 8 labs that are pre-warmed and ready. And then here, you're going to create the database, right? You're going to walk through the console and set up a database, right? Make sure that you check all of these options. If you miss one, things are going to get weird, right? Notice it says burstable classes and DBT3 small. Don't create an Aurora replica, right? So it's like, setting you up for some really clear things. Public access, no. VP security group, right? Just make sure you do all this explicitly. Put on your detail orientation. And then you're going to create the load balancer with some rules on it, including targeting a certain target group. You're going to review the DB metadata while the load balancer is kind of warming and loading up. You're going to test some application connectivity, and then you have an optional task, which is kind of fun, to create a read replica in a different AWS region, right? So at this point, you can go ahead and click on Start Lab and just get cracking. We're going to stop at 3 o'clock. So let's get it. But let me start
Alan,
recording.
I
Let
don't
me
see
share my
anything on
screen.
your screen. Alan, I'm sorry, Michael. There you go.
I'm sorry? I'm sorry, I didn't hear what you said.
It wasn't being shared before. Now I see it.
Oh, yeah. Okay. Good. So we've gone through fundamentals of architecture, well-architected framework, some of those pieces, IAM and organizations, talked about VPCs and subnets and internet gateways, had conversations about the variety of EC2 instances, their licensing types and whatnot. We've talked about block storage and file storage and object storage. We've had conversations about RDS, DynamoDB, Redshift, Elasticache, and some of the database migration. Well, the only database migration service, but it's got 2 pieces to it. And so, and then we talked about CloudWatch logs, all the various log types that are out there, like VPC logs and CloudTrail. And then we talked about autoscaling, and we had a conversation about load balancers. It's a lot. It's just a little bit like taking a class in college. You got the primer, now you got to go do a bunch of study, right? So now we're going to talk about automation. Now the check-in here is really about, have you used any of these provisioning tools? So this is actually a legitimate question. Have you used any of these tools to provision anything, anywhere? Okay. CloudFormation is a great tool if you're all into AWS. So is the CDK, which is you're all in AWS, right? CDK is the Cloud Development Kit, allows you to use a programming language. Nowadays, pretty much every engineer is expected to know how to code at least at basic level, and my recommendation is start with Python and go from there. Kyle, I see that you're learning Terraform and that you are doing some very basic provisioning, but you spend a lot of time in CloudFormation. I gotta tell you, once you learn how to use Terraform, it's really powerful, great to use, and you can also write configuration files with that tool for other providers as well. I would say that people are moving more towards code-based tools to manage this. So CloudFormation has its own domain-specific language. Terraform has its own domain-specific language, but they're moving more and more to kind of just pure code abstractions like Pulumi, the Cloud Development Kit, Crossplane API. Like they're moving more towards, writing things actually just as like, code, Python, Java, that kind of thing. So you're seeing that happen more and more. I don't know why Beanstalk is listed here because Beanstalk's kind of a wizard for the others, and you can't really infrastructure as code that thing. So it's kind of insulting, actually. They would use that as a resource provisioning tool because while it's a great best practice wizard for creating infrastructure, nobody who's serious about creating infrastructure at scale is going to be using Beanstalk. So don't really. I mean, that's like an industry known thing. I'm not sure why they put that there. They're not comparable. One of these things is not like the other. Here's the business kind of driver for this, right? Is that, we're trying to get agility, which includes repeatable deployments of infrastructure. That repeatability cannot be knocked, right? And how do we automate things so we can automate these responses and automate the deployment of virtual machines so that all of a sudden someone says, hey, we got to launch a new product tomorrow. You're like, easy. I got the entire environment in CloudFormation. I'll stand another copy of that thing up in 30 minutes to an hour, depending on what resources are started, right? So infrastructure as code, which I don't know why they don't spell this out. They just say AIC and assume that you're going to know that. That says infrastructure as code is the key to our success, which honestly is absolutely true for most businesses who are moving at pace, is that they are learning how to use CloudFormation. They're learning how to use Terraform. They're learning how to use the Cloud Development Kit or Pulumi or whatever, right? So anyway, I got to talk to them about this. So how do we get started with CloudFormation? All right, so how do we simplify builds? How do we deploy and scale in the cloud? How can we manage multiple resources as a single unit, right? So we're going to talk about CloudFormation templates, stacks, and how do you find reference architectures? That's what we're going to talk about. Now, first of all, ignore Beanstalk. I don't even know why it's here, honestly. It is, by the way, a useful tool if you want to enforce best practices and you want a wizard to ask you a bunch of questions. It's not infrastructure as code. So unless there's something that happened last week that I don't know about, it is a higher level service, but it's very manual. You're pretty much going to use the console for that. So, and they do have they used to have a Beanstalk tool that you could use. But like I said, these more modern approaches usually trump that. So I don't even know what's behind that, by the way. Hold on one second. Oh, EC2 is manual. Yeah, EC2 is manual. CloudFormation is kind of do-it-yourself, but so is Terraform. So I'm not really sure what they're trying to show here. I guess the convenience versus control, because it's true that Beanstalk actually makes a bunch of decisions for you, whereas CloudFormation and EC2 are going to give you a lot more control. So maybe that's where they're coming from. Now, that being said, if Beanstalk is really just a wizard, right, to EC2, what happens is that the cool thing about Beanstalk is you basically just give Beanstalk your code. It asks you a bunch of questions. Do you need a web server? Do you need a beta server? Do you want them to be highly available? Do you want synchronization? What kind of database server do you want? Do you want to run a Tomcat server? It asks you a bunch of questions, and then you can log into those boxes, but it pretty much takes care of everything for you. It uses CloudFormation to create a stack. Now, it will set up auto scaling for you as well and a load balancer. So, but again, it's all, kind of GUI based. It does generate CloudFormation that you can modify, but you don't really worry about logging in the instances. You just kind of let Beanstalk do it for you, right? So, cool product, not where you end up. You can start with Beanstalk, but you don't stay on Beanstalk. I actually had that conversation with a buddy who took over the reclamation of Equifax. I'm sure you heard about them having a little minor blow up. Anyway, he took over the reclamation architecture, and they were using Beanstalk like crazy at first because they had to get off of their existing data center. And man, it really messed them up. So again, you start with Beanstalk, but you don't stay with Beanstalk. That's not how you scale. So then when we talk about automation beyond Beanstalk, which again is just like a console wizard basically for running best practice EC2 instances, you're really starting to talk now about things like Systems Manager and CloudFormation. Now, Systems Manager handles the automation of running instances. CloudFormation provision those instances. This two-factor duet here of having a provisioner and then something to do configuration and ongoing maintenance. This is actually typically how old school people manage their infrastructure. And you might say, well, hold on, Michael, you just said old school people. In the sense of you've got a provisioner on the right and you've got some kind of configuration manager on the left-hand side. That's pretty much how we do it. Someone's got to get it up, get it so it's standing up, make sure it's working, ready to go, and then somebody else has got to manage it while it's running, right? The provisioner is the one who stands it up, and the systems manager would be the one who manages it while it's running. How do we patch it? How do we secure it? How do we run commands en masse across the fleet of systems? And so this is where we're going to focus on CloudFormation. So CloudFormation is the provisioner. Now, don't be fooled. I know that some of you have configured your systems using CloudFormation. There's absolutely nothing wrong with that. CloudFormation is not the best at that because you have to use Bash or PowerShell or their little proprietary cloud init thing, which is kind of clunky, quite frankly. But let's talk about CloudFormation and its infrastructure as code aspects, how you use stacks with it, CloudFormation templates in general, and then how do you like get things like solution implementations and cloud development kits, which can kind of like get you more native into code and give you some best practice templates. First, here's how CloudFormation works. Actually, I think I had a CloudFormation file open the other day. Hold on one second. Did I have one open the other day? Oh gosh, not found. Hold on one second. Let's see if we can dig one up here. You ever have like way too much information in your system and you realize you just kind of keep adding hard drives because you kind of organizing your information and you try to keep up with it, and then you realize that you're kind of wasting your time trying to keep up with everything. Hold on a second. Here we go. Let's try this. All right, so here's some CloudFormation. I was kind of joking about that, but we're all drowning in way too much information. So this is what CloudFormation looks like, right? Basically, in this particular space, we've got it's basically just a bunch of really domain-specific files that contains things like subnet definitions, and this particular section is actually just asking some questions, right? This section is called a parameter section. This section is going to ask you questions. If I take this file and I push it to the CloudFormation service, the first thing it's going to do is it's going to ask me any of the questions that I've defined in the parameter section. In other words, what VPC should I be using? What public subnet, right? What's the range for that subnet? And then is there an Amazon Linux ID I should be using? Now, in this case, they're actually pulling it from it looks like a parameter store value, right? And then the next section, which is actually required, is actually called resources. And this is where it's actually going to make something. Now, in this particular case, it's making a VPC, which I just call a VPC2, an internet gateway, public subnet, public route table, public route. It's creating all the things that we were doing manually in one of our labs, including an instance. And I called it, I didn't call it instance D. I actually got this from somebody else. And it's going to start a T2 micro. Now, notice it's using the lab instance security group. And by the way, this is the CloudFormation that we ingested when we were doing CloudFormation ingestion earlier, right? So, and then it's going to output the DNS name for the system in question. So this was actually all part of a lab I think we did at one point in time. Yeah, actually it is. You can see it now. That's it. Now there's a bunch of sections you can add to this. So here's an output section that's going to show you everything at the end. The resources section at the very beginning is the one that's required. There's a parameter section. You can add a conditional section. You can add a mapping section. There's all these sections that you can add into CloudFormation depending on how you want to structure it. I've seen some really complex CloudFormation. I'm sure you have too. So this file, by the way, can be checked into version control. So if I decide to change it, I can check it, check it out. What are we using, SVN? You can clone the repo, make your changes, and then push it to your main branch, and then you can, merge it with the main branch and then push it back to, the remote like system, right? Or you can do a pull request, whatever your strategy is for GitHub. And so this, by the way, gives you a version controlled way of tracking changes that are made to your infrastructure, because when CloudFormation, if you make a change and give it back to CloudFormation, it's going to make that change. So if you decide to change the instance size or change the image or whatnot, all that can then be tracked in a repository and then ingested by CloudFormation. There are tools now, by the way, where your repository can be constantly watched by CloudFormation, and when you make a commit and it's approved, it can get pushed to CloudFormation, and therefore it can push the change. So there are ways to do that now. But that's all this is that CloudFormation is nothing more than a file that contains some definitions. You give that file to the CloudFormation service, it ingests it, parses it, maybe asks you some questions and some permissions, and then it goes and creates all the resources that you want, assuming it has permissions to do so. So that's how this works. Take a file, a template, give it to the engine. The engine creates it creates a stack, like it interprets everything, and then it creates those resources. That's it. Now make it sound really simple, but orchestrating something from end to end, some pieces of that are really easy. Some pieces of that are really hard, actually. Like standing up a Jenkins server. What was I looking at the other day? Yeah, let's go take a look at this because this is kind of fun. No, not that. Where's the other one? Yeah, you. Come here. Let's see. Cloud of Knots. No, Wix. All right, so oh yeah, highly available master. Chicka, looking good. All right, so hold on, let's go back to a better one. All right, so let's say I'm out here, and by the way, I know these people, so I'm not super concerned about their templates. So make sure you pull templates. If you need to read them if you don't know who it is, right? All right, so in this particular case, this template requires, you can read this, right? But the other thing is that if I'm logged into AWS and I just click on this will literally launch this right into my account. Now, you notice that it's actually listing the template URL, which I'm usually just going to grab in this case. And it has been readily downloaded. So we'll move this out of the way so we can look at this in its entirety. This, as I scroll through it, is a really long, it's a really long like CloudFormation file. And there's probably better ways to do some of this, but this is going to create, like, for example, an alarm, right? And so this gets super complicated. Writing this kind of thing from scratch is a long process. But once you get this kind of thing done, by the way, anybody in the world can use it as long as you don't have any account specific dependencies, right? So if we go back to my account, notice that this is going to create a Jenkins stack, right? Assuming that I, actually have a VPC name, right? Which I don't, so I can't. But it's going to ask me all these questions. If I answer these questions appropriately and click on Create Stack, it's going to create a highly available Jenkins server in my account. Now, it's going to use virtual machines, which I would never do now. But this is pretty solid. And converting that over to a container is actually easier than running it in a virtual machine. So these kind of like CloudFormation templates can be shared with anybody that need to be shared, especially inside your own company. So they really are perfect for this, for infrastructure as code. Now, once you have the template defined, obviously you probably want to use an editor like the one I was using just to make sure that everything's solid. And then the benefits of this is just you get reusability, you get repeatability, you can get actually differentiation. So you can make it ask you questions like, is this development or production? And if it's production, it does different things in the template than if it's, right, development. You can also update a security group in the template, and when you reapply it, it's going to update all the security groups inside of all accounts. Now, that might sound like a disaster to you, so if you don't want that, you don't have to do that. You can have a separate template for production, a separate template for development. That's up to you, right? Now, CloudFormation works where you take a JSON or YAML template using Amazon's proprietary domain-specific language, right? You upload it to the service translates it into basically a stack, and then it creates the stack. Stack sets, by the way, can be created, which allows you to share stacks and push those stacks across all the accounts inside of your AWS organizations. Now, the template itself is either JSON or YAML, right? And, we already talked a little bit about the sections, but it's got like a resources section, a parameter section. There's other sections that you can add depending on what kind of like code sophistication you want to add. You can create these stacks, which are basically collections of AWS resources. These stacks show up in your CloudFormation service. I don't think, let me just check really quick and see if I have a stack to show you. If I don't, I'm such a slacker. Let's take a look at CloudFormation. All right, so I got Cloud 9. Here's a control tower. So if we go look at this stack, by the way, if we go look at the template, first of all, the user data is all encoded. It's like base 64 encoded. That's fine. We could de-encode it. Notice that I created a T3 medium with this. These is just a resource section. I didn't even create this, by the way. This was created by Cloud9. Notice it has the security groups, including all these rules set up for security ingress, right? Here's a little tag for it. If I want to know about this system, there's no outputs defined because the template didn't have any outputs. It didn't really ask me any questions either, so there's nothing here. Here are the resources it created, which was an instance and an instance security group, and that's it. Now, if I'm worried about this whole thing, I could like go in and detect some drift and say, hey, can you tell me if something changed between what I made and what's out there right now? And so this is the entire stack info. So this was done successfully. Oh, but look at that. Looks like some things drifted. So I'm kind of curious. Let's go look at the drift results. My instance was modified and my instance security group was modified. Really? Interesting. Let's go look at the drift details. Oh, my associated public IP address was removed. Isn't that fascinating? Let's go look again. What changed about my security groups? Someone removed an ingress, removed port 22. Well, I say someone. Come on, it's me. I'm the only one with it. So they expected this, but instead, looks like a bunch of things were changed, right? My point being is that change sets like this allow you to both change things from the CloudFormation template. Drift detection allows you to detect when someone's changed your resource and it doesn't match what's in your template. Super cool, right? So not only can you create a change set where you actually are changing that document over time and you can apply those changes. So you're pushing from CloudFormation against the resources, but you can run drift detection like you just saw me do to detect whether or not the resources have changed based on what you asked them to be inside the CloudFormation template. So CloudFormation has a bunch of really cool aspects to it. So the anatomy of a template, we talked about this just briefly, but resources is the most required one. As far as like description and template format and metadata and parameters, mappings, all that stuff, those are all different sections of it. There's also, is transforms listed here? Oh yeah, it is listed here. Transforms is often not listed, so. But there's several major sections. Transforms is mainly used for like serverless. So now I'm not going to go through all these pieces because this isn't an operations class, but just know that these are the different sections. You're going to want to read the documentation to look at the template anatomy. So what people typically do is that there's one group that will control identity in the organization, and they'll push that out to all the accounts in an organization. Then another group is responsible for networking. And usually they'll work with a security team and they'll push that out. And then there's some shared services, right? Not just networking. Could be shared databases. Could be a shared like routes server of some type, right? Could be a shared configuration management server. Could be a shared provisioning server. Could be a shared CI/CD server. That comes into a shared template. And so each of these like stacks can refer to another CloudFormation stack. So that way a group can independently update their stack and break everybody's stuff all down the chain. I'm just kidding. That's what you don't want to have happen. But people can do that where they change a stack and the next thing you know, 5 things break down the line. So you got to test things, just to say this testing is still king, not in production, right? Now, AWS does have these things called solution implementations. So these are verifiable deployments that you can make. So if you're like, you know what, I really absolutely love like Kubernetes, which is not true. Let's say you want to use Rancher. This, if you click on this, actually, this will allow you to view a deployment guide, and this deployment guide will walk you step by step through everything you need to do to deploy Rancher. Some of these are pretty old, so make sure you check them because most of these tend to work, but sometimes they don't. So Just if you can see the date, make sure you check it. I remember seeing the date. Oh, see, so she says last updated on February 21st. That's good. Most of these look like they've been updated fairly recently. That one's a little June is a little suspect. But bottom line, if it's older than 2 years, it's probably broken. So like these February 2019 ones, they're probably going to work. But I got to tell you, that's approaching 3 years old at this point in time, right? Because February 2022 is right around the corner. There's probably better ways to do it now if it's like that old. So, such something to know is that when you run these, don't expect a whole lot out of them unless they've been updated in the last year. Okay. OpenShift. Wow, look at all the Kubernetes stuff in there. They're killing it. These are called solution implementations. They are actually in your student guide. I'm going to post them here just in case. Now, the other thing to note is that there's a cloud development kit that you can use if you're really like code friendly. Now, I'm going to share this with you because I think this is an awesome little resource. There's a CDK workshop that you can run that will allow you to practice using your favorite language to write CloudFormation templates. I know that sounds strange, but like in the Python workshop as an example, since I know Python the best, it'll basically show you how to use this CDK tool to initialize basically a CDK project, and then it'll do some things with Python like install requirements and stuff like that, allow you to explore your project directory, and then what you'll do is you'll actually import the entire CDK set, and then notice here it's like starting to set up basically an app, right? So what will happen here is that from the import, you're going to import a bunch of pieces, including SQS, SNS, and a subscription. And then look at this. You're actually setting up an SQS queue. You're setting up a topic, and you're actually just calling that particular, like subscribing the queue basically to the topic, right? It's all in code. If you're not comfortable with code, I'm going to tell you right now, and I come from the operations side of things, not as a developer. I have never been a feature programmer. But I'm going to tell you right now, you want a career in IT? I hate to say this, but you have to become at least code conversant, right? Especially if you're working in any kind of technical field. Automation is king for scale nowadays, and this is what they're looking for. All right, so this CDK workshop is rock solid. It's a good little thing. It will require a free account to work. It might cost you, I don't know, 25 cents, maybe less. So, especially if you have free tier activated on your system, like your account's not older than a year, you probably pay nothing, honestly. Okay. So that's the CloudFormation automation piece, is that there's a cloud development kit. Terraform is a third-party tool. You can learn from them. Pulumi, P-U-L-U-M-I, Pulumi. Yeah, Pulumi, P-U-L-U-M-I. That's a more agnostic kind of like version of Terraform, but it works like the cloud development kit. It uses code to write stuff. So the cloud development kit, only has like 6 languages with it, but it allows you to be more programmatic with your use of CloudFormation. That was all just provisioning. Let's talk a little bit about Systems Manager. Now, this is really going to be a skim. Here's what you need to know about Systems Manager. There are 17 subsurfaces under Systems Manager, and everything in Systems Manager is designed to help you manage a fleet of EC2 systems. But just to say this, some of the tools actually can be used to manage a lot of things, but EC2 is the primary focus. What does it do? It's got a patch manager, it has maintenance windows, it has security and compliance reports. It can, by the way, it'll do your on-premise servers as well as your AWS servers. You can do all kinds of automation and visibility tasks. It's got operations management, application management. It can, do a change calendar. You can run commands off an entire fleet of systems. This isn't even all the services that are in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 3 missing here, right? Actually, there's probably 18 now. So what you need to know is that this can install software for you. It can manage your sessions. It can stop and start your instances on a timetable. Obviously, you see Patch Manager there. It can run inventory about all your third-party software and operating system statuses. I did just make that word up, by the way. It can host parameters for you. So if you want to like store variables that are used in some kind of automation setup, you can do that. If you want to do application configuration on the fly, it can do that. If you want a central place to see all of your issues with your fleet of systems, you've got Ops Center for that. So the main takeaway you should know about Systems Manager is that it is a big, big product, and it's got pretty much everything you need to manage a fleet of EC2 virtual machines. My only problem with Systems Manager is that most people have already solved this in their enterprise. Most people already have a patch management system. Most people are using jump boxes. People already know their maintenance windows. But those tools are not necessarily as sophisticated, as integrated, not sophisticated, integrated as these tools are. But my problem is that, most large enterprises have already figured out how to do this. They're using like ServiceNow, or they're using some kind of patch management system. But these tools are actually pretty solid. So you got an existing system, stick with that. You're looking to replace it, you might want to look at Systems Manager. Okay, let's do a knowledge check. What is a CloudFormation stack? Someone tell me. Good. It is actually indeed the resources generated by a template, right? That's a stack through and through. Okay, what section is required in a template? I think we said this and it was highlighted a couple times. What is required to run a template? Good. Resources. Got to create something, right? If you're not creating anything, why are you submitting a template? That's what resources is. Okay. Which of the following are benefits of using the CDK with CloudFormation? I love B, by the way. Bulk discounts are automatically applied. No. Boy, if that was the thing, we'd all be using the CDK. Developers can use known languages. Yep, sure. Like you saw my list of languages when I pulled up the CDK workshop. Developers can call pre-configured resources with proven defaults. Yes, you can. Right? In other words, your code is like super repeatable. Components are limited to a single user. That's not true. And using the CDK doesn't require an account. That doesn't even make any sense. You can't do anything in AWS without an account or credentials. So unless you're accessing an application that doesn't, like a public web server or something. So. All right. That was the module on automation. There is an introduction to CloudFormation out there on QuickLabs, amazon.quicklabs.com, not the official AWS side, web age, but amazon.quicklabs.com. So if you want that, feel free to tool around with that. I think I got a message earlier that I think some of you got an email indicating that you now have access to QuickLabs or have credits. So we're going to confirm that for tomorrow. All right. Dude. Let's see. Did it finish processing? Hello, video. No, let's go look and see. Hold on. See what my videos are doing. You get to see all my sorted videos back here. Man, that thing is still processing. Huh. Okay. All right. We're gonna let you keep going then. I'm gonna upload the other one as soon as possible. Oh well. Okay. So let's bring up containers. This topic, by the way, I could argue is probably going to be the most important topic next to serverless that we could talk about. And this is not deploying containers on AWS. This is not deploying microservices on EKS, right? But if you're not working with containers already, you will be. And I hate to say that because like code and container, all this stuff is like, taking over the world, making jobs in some cases requiring us to grow more skills as we deal with more and more complexity. But like I said, human beings like to make things tough. So, in some ways we're abstracting things away for some people and making it harder for other people, but that's always the way it is. So let's talk about containers, because containers offer some measure of simplicity, but they can also complicate your life. So how many of you, by the way, here's a better question. How many of you are actually using containers now? How many of you have actually used a Docker file to create a container? Okay, I'm gonna take that as a no across the board. So this is gonna be interesting then. So, oh, good, Ryan, for personal projects, cool. So just know that most people are trying to go to a 100% containerized architecture. Developers support that. Even the operations folks will support that. And re-architecting something into a container is actually not that tough. Containers don't have any size limitations, but there are reasonable size containers. And so pretty much, since it's just process virtualization, it's not hard actually. If you can deploy your project into a virtual machine, you can deploy it into a container on a virtual machine. Now, why would you do that? Well, this is process isolation. So containers are actually lighter weight, typically faster to boot, and more portable, at least across virtual machines, than like a virtual machine is. They're just not as large because they're just the application. So let's talk about it. So when is it better to use containers for your compute needs? What do you have if you want to make applications highly available and scalable in containers? Do we have an infrastructure agnostic portable application environment? So this is where instead of using app servers, we might actually use like ECS or EKS instead, right? We might use a service. But before we talk about this, we kind of have to talk about microservices first. Then we can talk about containers. And then we can talk about the things that run and host containers, right? So kind of a fun conversation, because there's containers and then there's running containers in production. And running containers in production requires a container orchestrator, which Amazon has 2 of them. I do not know why, but I know what they're used for. All right, so let's talk about microservices. First of all, if someone tells you should use microservices and they haven't asked you any questions, you should tell them to go away. Here's the challenge. Right now, one of the things that happens is we have these large monolithic applications that are all the code is tightly coupled, and as it should be, because it's all written in one language like Java or whatnot. But when you need to scale an application that has like credit card management, profile management, web presentation in it, you have to scale that whole thing. You have to take the entire monolithic application and repeat the whole thing, even if the only thing you really wanted to do was scale credit card billing. Because everything relevant to the product is inside of one code base that's launched at one point in time. So that kind of like tight coupling, that's an anti-pattern in almost every modern application design, right? And whether it's web servers that are being loosely coupled against the application servers, or this big honking like 32 gig resident memory application that needs to be split into a bunch of smaller applications so they can scale independently and developer teams can work independently. One of the main reasons to actually go to a microservice pattern is because your developers are being slowed down by each other because all of your business concerns are on one application. So when your tech debt slows you down from releasing, that's when you need to start looking at maybe decomposing your monolithic application into a microservice. But just to say that, if your application is working fine and you just gotten started and you don't have 50 teams to work on an application, then leave it as a monolith. You don't have to convert it to a microservice. Who cares? Right? In other words, there's no panacea. So if it doesn't fit the criteria, you're not feeling pain to move it to a microservice, then don't move it to a microservice. You move it to a microservice when you actually need the benefits of a microservice, which is independent scalability, independent deployability for a single product. So for example, if users, topics, and messages was all in one monolithic application, what you could do instead is you could split it into independently scalable and independently deployable applications or services called microservices if you actually needed to do that. Now, I got to tell you, a lot of applications could benefit from moving to microservices, but they all start as monoliths. So this does allow for specialization, different languages. By the way, these microservices usually talk to each other through APIs. They don't actually talk to each other through like inter-process memory calls like RPC or whatever. They don't do that anymore, right? Because they're independent, right? And so they're in their own separate like servers / containers, and so they talk to each other through these APIs. Now, let's say you want to take a monolith and split it up like this, and you got a user service, a topic service, and a message service, but it all lands at the same URL, like magicforums.com. How do you make that happen? Well, let's say example.com is your URL, not Magic Forums, although I think Magic Forums is a better example. You would terminate that URL at a load balancer, and if someone was trying to get to example.com/users, they would go to a different microservice than /topics or /messages. So, and this could be a mix of EC2, Lambda functions. It could be an ECS cluster, which is the Elastic Container Service. It could be an EKS cluster, which is the Elastic Kubernetes Service. So microservices don't follow a one-size-all approach. And by the way, all those could be in different languages. You could have .NET on EC2. You could have Python on Lambda. You could have, Java on your ECS cluster. Now, the cost of a The cost of doing something like this is that you went from one application to 3 that are all independently scalable. So as you can imagine, you just added some complexity to your system. So you're going to need to manage that complexity. And by the way, people have written software so you can manage that complexity really easily. Containerization like virtualizes the application, but a container orchestrator manages the containers. So they manage all these services. So while all of these could fit into containers or they could be on an operating system, it doesn't really matter. This is what microservices gets you, is this kind of independent scalability, independent specialization. Now, I mentioned complexity. The other problem is then how do you actually track how a user flows through your entire system? What if they go to a topic and post a message? How do you track where they are in your flow through all of your services? Well, Amazon has an answer for that. It's called tracing. That's the open, like the industry standard for it. And they have an X-ray tracer that will trace your applications from the minute a user hits your code and how they run all the way through everything. So they do actually can grant you visibility into how you flow through all of AWS's services and how you get back to the user. So if you haven't used X-ray, X-ray is spectacular at giving you this service lens map that shows you the latency of how a user flows through all of your AWS services and flows back in again. And if you've never used it, yeah, you might want to go look at the X-ray documentation because it's pretty cool, actually. So this provides end-to-end for a single user session how that user experience went inside of your application. Excuse me. Now that's just a discussion about microservices. Let's talk about containers. So containers, it's like, what's the difference between a container and a virtual machine? Michael, you said process isolation. What application virtualization? What does that mean exactly? Well, just to say this is all this does, by the way. If the purple one is Ruby and the triangle is Python and the square is .NET and the green rectangle is Java, That's literally what it looks like when you go to deploy these things. They do not follow a standard deployment model. Java uses Maven and blah, blah, blah. If it's JavaScript, it's using NVM. You could be using Sinatra or Capistrano for Ruby. Python's going to have Flask and right? Instead, if you stick them in the same format, then all you have to worry about is dealing with the format and not with the deployment model that's inside or the JVM that's inside or any of that stuff. This is what we're looking for. It is no different from the gentleman in like 1958 who, is it 1958? Is that right? I guess that is right, actually. 1958, I think it was Tatlinger and McLean who basically patented the shipping container. So they patented the shipping container. No one cared from now on if there were bananas or computer chips in there or tires, because now everything could stack up. So if you had the infrastructure to deal with a container, like a shipping container, then you had the infrastructure to ship that container and make it available and move it around and put it on a truck and all this other stuff. That's all we're doing with containerization. This is not like some kind of like special magic. What we're doing is we're putting a wrapper around Ruby, a wrapper around Python applications, a wrapper around Java. We're just literally putting them in a wrapper so that we can carry them, move them, and deploy them just like this. So as long as I have the containerization software and the right OS, just caveating that, you can't put a Linux container on a Windows box, right? If I have the right software and the right OS, I can basically deploy this thing out. That means if I put this on 50 different ships, as long as they all have the same OS and the same containerization software, they're going to run that application. It's going to run. I don't have to worry about libraries. I don't have to worry about system libraries because everything's in the container for the application to run. So I just pick that application up, throw it onto another box. I can duplicate it 50 times over. It runs. This is the value of containers, is that repeatability, that portability, and then, of course, horizontal scale, right? Because I can just keep copying these containers off. Now, containers contain everything you need inside that little container. So that's the runtime engine, any dependencies, right, for environmental consistency, the configuration, and how to run that code. It is all inside the container. This is not running a kernel. This is not a virtual machine. And I know some of you are like, but hold on, Michael. I can put Ubuntu inside of a container. I know you can. But what you're actually doing is you're actually running the binary of Ubuntu, which is why that thing won't work on a Windows box. You have to run it on a Linux box because it's going to talk to the kernel. So you're not actually putting a kernel in there. You're just putting the Ubuntu binaries into container. It's probably going to either run on an Ubuntu box or a RHEL box. Doesn't matter. As long as those kernel calls match, it's going to be able to do that. And by the way, they do. So Kyle, you're actually right. A container is going to share the kernel of the host that it's sitting on, which is why a program compiled for Windows has to run on Windows. It won't run on Linux. A container compiled for Linux has to run on Linux. It can't run on Windows. That's the only, that in the processor architecture, just to mention that. You're not going to compile something for ARM and have it run on x86. That's not going to happen, okay? So, but for the most part, those are boundaries that we don't worry about. We typically run the same operating systems, right? Maybe Windows and Linux, that's it, right? These things, by the way, are small. So instead of a 2 gig or a 5 gig, operating system cost, these things boot up in seconds, like seconds. It's crazy. And they're like 40, megabytes or 100 megabytes in size. And they're just fast. So containers, they're not a panacea, so don't get me wrong. They don't have the answer to everybody's problems, but they're pretty cool, actually. So here with our monolithic ordering application, instead, we take this out, put them in services, and then everybody can share inventory, everybody can share order history, whatnot, right? So instead of having these 3 apps, these monolithic apps that make up this, and there's duplication, like inventory is duplicated, sales history is duplicated, instead we make this a product where everything is running in microservices. Now, they really simplify this. This could be dumb, actually, right? But a lot of times, if you can understand the journey that you're making, it could be worth it. It also could be worth it for you to just stay where you're at. And there are tons of design patterns for how to convert from a monolith to a microservice. So, that's a whole class in and of itself. Actually, I teach that class. So there is a class for that. Here's the thought, by the way. So here we are on the left-hand side running on bare metal systems. Our apps are sitting on libraries that talk directly to the operating system. If it's a virtual machine, you can take that virtual machine, by the way, imagine you're placing 3 of these or 50 of these on top of the bare metal server, because that's what happens, right? Now what happens is that you are copying the guest operating system again and again and again and again. But do you actually need the operating system? This is the world we're shifting to, by the way, is people are caring very little about the operating system. We are moving away from giving 2 junks about whether it's Windows or Linux. And quite frankly, everybody's running Linux or they're running a very simplified Windows version, but they're getting away. Even Microsoft's in the Linux game now. So what's happening is people are stripping down to these kernels that are built for containers because they don't want to have to deal with the operating system, attack vectors, patching, all that stuff anymore. I mean, you still have to, but they want to slim the footprint down. So when you throw in containers in here, here's what happens is that you still need an operating system. You still need a virtual machine or a physical machine to run these containers. But first of all, that library thing that's running at the bottom there that looks like it's shared across all the containers, that's not going to happen. I don't know who drew this drawing, but that's inaccurate. Just to say this is what this should look like. Oh, hi, I didn't even know I could do that actually. This should all be these should be independent from each other, right? So everything that's needed for container A should be wrapped up in container A, right? Same here for container B. Wow, these drawing tools are horrible. And then container C, right? All independent. You're not going to share libraries across containers. That's not going to happen. We're not doing that. So everything should be in the container so that container can independently execute. It shouldn't be dependent on any other container to function, at least as far as like startup, right? It might need to talk to other services to function as part of a product. So imagine you're not replicating the operating system anymore. All you're replicating is the application. Yeah, that's a good point, Kyle. Not to mention virtualizing physical hardware, right? Don't get me wrong, containers have like a fake network. It's not really a network card. They just have abstractions around networking, but they don't have virtual hardware. There's no virtual hardware in a container because there's no kernel to talk to the virtual hardware because all it is an application. But I do want to point out, we're not getting away from virtual machines. Containers have to run inside of an operating system, but they try to put everything they need in the container and not in the operating system. Note that you still need that containerization platform to function. Other things worth mentioning. Assuming that Michael can find his mouse. Oh, wait, hold on. Here's what you're doing. Can we erase everything? Thanks. All right. So let's take a look at this again. We got virtual machines. We're copying the operating system again and again and again. Containers, always, and it says Docker engine. First of all, you're not going to run Docker in production. I don't even know why that's there, right? I'm not saying you're not going to run Docker containers, but you're not going to run the Docker engine in production. You're going to use some kind of orchestrator, which is actually going to be Kubernetes or something proprietary, right? But like if you're just running it on your local system, like your laptop, yeah, you'll have a Docker engine there, but you're not going to do that in production. So here you've got containers, then you've got the Docker engine, then you've got the operating system, and then the server. So this is a perfect example of how it works on your laptop. And actually, it does work like that in production as well, but that purple Docker engine gets replaced with what's called a container orchestrator. So if you decide, by the way, to run this on an EC2 virtual machine, you're going to have to manage, by the way, yourself, the deployment of all these containers. And some people will be like, well, I'll just use Docker Swarm. Well, Docker Swarm, by the way, uses Kubernetes. So you're going to be using a container orchestrator, which we're going to talk about in just a second. My point in all this is that if you run 3 virtual machines, which, here you've got a guest OS and then another guest OS, another guest OS, you can run containers all over those things. But how you manage those is actually really hard, because unless you have an orchestration system for your containers, you're going to be doing all this manually. And let me tell you, like I did a proof of concept for the NFL, 49,000 containers. You better believe that we were not doing anything manually, right? So just know that this is a cool little diagram about what you could do if you had like 3 machines and you wanted to kick some containers out there, but you actually have to have something to manage the containers to push those at scale. That's where this comes in. So that was just all containers. Any questions about that? All right. Let's talk about container services. In a world with containers, one system called Kubernetes dared to step up. I'm just kidding. That's not true, actually. I don't know what happened, but there used to be a lot of container orchestrators. There was like 4 or 5, including, by the way, Docker Swarm, which had its own stuff, and Rancher, which had its own container orchestrator called Cattle. And then something happened. I don't know if they got into a fist fight or they just came to an agreement. Maybe there was like a peace accord or something. And everybody was like, you know what? Kubernetes is king. And then everybody else pretty much died. Rancher stopped making Cattle. Docker sold Docker Swarm off to another company called Mirantis. So Docker Enterprise, I think was actually the name of it. So Docker sold their own like enterprise orchestrator, which is kind of just like, huh? Maybe they needed the money. I don't know. But then Kubernetes came along. Kubernetes was originally made by Google, and then Google gave it to the world. It got adopted by a company called a consortium called the CNCF, which is the Cloud Native Computing Foundation. And then the rest is history. Kubernetes is now by far the de facto #1 container orchestrator in the world. But here's the cool thing. Before Kubernetes rose to prominence, Amazon released their own container orchestrator called the Elastic Container Service. So Amazon's got 2 really actually pretty cool container services, and both of them, by the way, require this. In order to actually use Kubernetes or containers in production, you have to take the container image, which is like an AMI for containers, and you have to stick it on a registry. Why they keep shorthanding these names, I have no idea. The Elastic Container Registry is what that stands for. What happens is that you copy your software up to the Elastic Container Registry, and when you say, I want to deploy it 50 times, those 50 servers download that software from this container registry. So you have to have some kind of Docker registry or container registry. ECR is Amazon's answer to that. You have to use something like this in order to download the software and install it. Think of it like, using Chocolatey or apt on Linux or NPM or whatever package manager you want to think about. But the ECR is the repository where you download the images that you push to it. The most famous registry in the entire world is called hub.docker.com. And that is where almost all systems by default go and pull their images down. So whether it's Nginx, Postgres, Redis, you can go to hub.docker.com and pull everything down. ECR is used when you want to create a private registry, although it does have a public aspect to it if you want it. Now, once you get your container images, let's say it's users, topics, and messages, into the registry, you can then deploy it into a service like ECS. The Elastic Container Service is Amazon's proprietary container orchestrator. It is way easier to use than Kubernetes, and it does not have any of the standard Kubernetes integrations. They also have a version of this called ECS Anywhere that you can run on your local data center if you want to. So here you can convert all of your stuff into ECS and run it on EC2 instances. ECS, by the way, is going to allow you to specify the number of containers that you want for each of your products, and it will deploy it across either EC2 virtual machines, or it will run it in what's called Fargate mode, which actually stands for serverless. If I can find out who called it Fargate, I'm going to give them a piece of my mind. I don't know why they didn't just call it serverless. They called it Fargate instead. I don't know if it's because they liked Farscape and they liked Stargate, and they wanted to put those two things together. But when you hear the word Fargate, I want you to think serverless. And if you ever find the guy, send me an email, or girl, I'm not, it could be anybody, right? And just, let me know who they are. So I just want to tell them, why? Why didn't you just call Fargate serverless? Anyway, ECS runs in EC2 mode, or it runs in Fargate mode. EC2 mode does exactly what you think it does. It runs EC2 virtual machines, and you stick your containers on there. Fargate mode does serverless, so that means you run the containers, but you don't see the underlying servers. Okay? So a reminder, ECS is Amazon's proprietary elastic container service. So easier to use, not as industry standard or industry friendly. Now, what do they have that is industry standard and industry friendly? Well, they got Kubernetes. I feel like you could go to a conference and yell Kubernetes sucks if you really want some attention. Don't do that, because Kubernetes actually doesn't suck. But EKS, which is the Elastic Kubernetes Service, also has an EC2 mode and a Fargate mode. Kubernetes you can run Kubernetes anywhere. Amazon, this is an open source project. Amazon just happened in 2018 to make this a competitive product. By the way, Google has it, Microsoft has it as well. I got to tell you though, the Amazon's version of it is actually pretty decent. Let's be honest though, Google made this thing, so their version of it is the best. So in case you're wondering, GKE is king, right? But I got to tell you, Amazon's is actually pretty rock solid, right? This is going to let you set up and run a Kubernetes cluster, just like you can run an ECS cluster. You can run an EKS cluster. It is Kubernetes, which means all of the standard Kubernetes extensions and tools. This is a certified distribution of Kubernetes. So this is CNCF certified, which means it's going to work with any tool you want to throw at it, with very rare exception. The way this works, same thing. You define your pods or deployments inside Kubernetes. You define your workload, and either you're going to run it in Fargate mode, which is serverless, or you're going to run it in EC2 mode. You can see the two modes there. And it's going to download the containers, run them, and then you can either connect to them and manage them, or you can actually connect to your applications. So all the plugins and tooling from the Kubernetes community is going to work in this particular case. Okay. Now, the architecture of Kubernetes is that there are some hidden leader servers called the control plane here, but all of your containers are going to run in pods that's on what's called the data plane. What part of this is the data plane, the worker nodes? Fargate or EC2. Those are the worker nodes, meaning the containers are either going to run in serverless mode or they're going to run on servers. That's part of the data plane or the worker mode plane. So all of this, as far as the kubelet and the kube proxy and the container runtime, that's awesome that you can see that, but don't worry about that. Just know that you're going to run containers on the worker nodes, and that doesn't work any different than it does here with ECS. These EC2 instances are worker nodes. So ECS and EKS work remarkably similar, but EKS is actually Kubernetes compliant. Okay. Now, I mentioned Fargate before. Fargate means serverless. Why do they call it serverless? I've already ranted about that, so we're going to skip it. Just makes me mad. So Fargate means serverless. That's all you need to know. They literally, by the way, in case you want to know under the covers, they start a virtual machine that is 256 megs bigger memory-wise than the container you requested. They're called micro virtual machines, and they make them just for your containers, which cracks me up. Has a tiny little operating system inside of it. Your container runs inside of it. You're good. You don't see that virtual machine, by the way. The only reason I know that is because I read some of the backend stuff. Fargate works serverless with both ECS and EKS. You do not have to manage any servers with Fargate. Now, which one do you choose? I'm going to make it this easy for you. If you're doing something really simple and you don't need Kubernetes or you don't know Kubernetes, then use ECS. If you need industry standard compatibility, you're going to use EKS. If you need super tight integration with AWS, then you're going to use ECS. If you're like, I can have some integration with AWS, but I really just want containers, then just use EKS, right? Both of them, by the way, have an on-premise version called EKS Anywhere. So, and both of them have Fargate serverless. Both have EC2 launch types. Yeah. Now, does this make more sense now? We have started, we saw this at the very beginning where we talked about how EC2 is infrastructure as a service, so you get control of the operating system, but you're responsible, in exchange for that control, you're responsible for patching everything. ECS and EKS, along with the serverless version of both of these called Fargate, those are containers. As you move up to Fargate, you are now into serverless world, and so you don't have any servers to manage. Amazon's got that for you. And then when you get into Lambda, there's even less to manage. All you have to do is manage the application code, right? So there's even less to do there than there was with Lambda. I'm sorry, than with ECS and EKS. So Lambda is at the top of the food chain as far as abstractions go, but you have less control. Does that matter? Some people it does matter. So that's why I let you know. Okay, we're at the end of the day. I got a little knowledge check for you. There's no lab for this one, so we're going to pick it up tomorrow. Does anyone have any questions about that entire fire hose of containers that I just presented to you? Okay. It's a lot. Here's a little knowledge check. What are some of the characteristics of microservices? One of which was on the slide, the other one I kind of ranted about, right? Good. Yeah, loosely coupled, autonomous, and independent. I hope I stressed that enough. They are independently scalable, deployable, autonomous code bases, right? Loosely coupled is key also. Okay. Which of the two are following of characteristics of containers? Hit me with your best shot. I gotta tell you, one of the answers here actually I feel like could be part of the equation, especially the repeatability one. I think what they're looking for though is they're definitely not looking for automatic, right? They're definitely not looking for hypervisor. Portable, scalable, and repeatable are really what they're looking for here, right? Shipping containers, right? And unlike shipping containers, you can copy them, because if we could copy shipping containers, we'd probably all be rich or something. Portable, scalable, and repeatable. Containers and Amazon ECS are logically organized into what? By the way, I didn't really clarify this. Remember that Kubernetes uses pods, but ECS doesn't, right? But what do the containers go into? It's a collection of machines called a, what's a collection of machines, right? That serves a single purpose, right? It goes into an ECS cluster, an EKS cluster. By the way, if you were sitting there thinking, hey, ECS deploys into pods, you'd be right if it was a Kubernetes, but it's not Kubernetes. ECS doesn't do that. They call them tasks. Amazon. All right, which of the following are components of Kubernetes architecture? I made a big stink about the worker nodes, right, being in this kind of like State of existence. Which two, by the way? There's two of them. Yeah. Data plane and control plane. Control plane runs the cluster. Data plane does the work of the applications. It hosts the applications. Cool. Data plane and control plane. Why would you select to deploy your containers to Fargate over EC2? What? Why would you go serverless? Jorge, you are dead on. We want to avoid manual infrastructure updates. You too, Ryan. Right? We don't want to deal with infrastructure. I just want to run my application. Amazon, fix this. You do the thing with the infrastructure. I just want to run my app. Okay? Good. That's it. We're done. It is exactly 5:58. We covered exam cram stuff earlier. We're going to do the same thing tomorrow. We're going to cover it right after lunch. We're going to do some practice questions. The recording is being uploaded, so you now have the URL. You're also going to get an email with the URL. Does anyone have any questions for me? All right. You all have a good night. Let's close it down for the night. I'll see you tomorrow at 9:30, and we'll pick it up from there, okay? Remember, we're taking lunch at noon, so if you're making plans, remember we're taking lunch at noon tomorrow, okay? So I'll see you tomorrow at 9:30, though. We're starting at the same time. All right, y'all. Have a good night.